well, let me ask about the AGI community broadly. You kind of represent some of the most serious work on AGI, so at least earlier. And DeepMind represents serious work on AGI these days. But why, in your sense, is the AGI community so small, or has been so small until maybe DeepMind came along? Like, why aren't more people seriously working on human level and superhuman level intelligence from a formal perspective?
Okay, from a formal perspective, that's sort of an extra point. So I think there are a couple of reasons. I mean, AI came in waves, right? AI winters and AI summers, and then there were big promises which were not fulfilled, and people got disappointed. But narrow AI, or solving particular problems which seem to require intelligence, was always to some extent successful, and there were improvements, small steps. And if you build something which is, useful for society or industrial useful, then there's a lot of funding. So I guess it was in parts the money, which drives people to develop specific systems solving specific tasks. But you would think that, at least in university, you should be able to do ivory tower research. And that was probably better a long time ago, but even nowadays, there's quite some pressure of doing applied research or translational research. And, it's harder to get grants as a theorist. So that also drives people away. It's maybe also harder attacking the general intelligence problem. So I think enough people, maybe a small number, were still interested in formalizing intelligence and thinking of general intelligence, but not much came up, right? Or not much great stuff came up.
So what do you think? We talked about the formal big light at the end of the tunnel, but from the engineering perspective, what do you think it takes to build an AGI system? And I don't know if that's a stupid question or a distinct question from everything we've been talking about at IHC, but what do you see as the steps that are necessary to take to start to try to build something?
So you want a blueprint now, and then you go off and do it?
That's the whole point of this conversation. I'm trying to squeeze that in there. Now, what's your intuition? Is it in the robotic space, or something that has a body and tries to explore the world? Is it in the reinforcement learning space, like the efforts with AlphaZero and AlphaStar that are kind of exploring how you can solve it through in the simulation in the gaming world? Is there stuff in sort of all the transformer work in natural language processing, sort of maybe attacking the open domain dialogue? Like where do you see the promising pathways?
Let me pick the embodiment maybe. Embodiment is important, yes and no. I don't believe that we need a physical robot walking or rolling around, interacting with the real world in order to achieve AGI. And I think it's more of a distraction probably than helpful. It's sort of confusing the body with the mind. For industrial applications or near-term applications, of course, we need robots for all kinds of things. Yeah, but for solving the big problem, at least at this stage, I think it's not necessary. But the answer is also yes, that I think the most promising approach is that you have an agent, and that can be a virtual agent, in a computer interacting with an environment, possibly a 3D simulated environment like in many computer games, and you train and learn the agent, even if you don't intend to later put it sort of this algorithm in a robot brain and leave it forever in the virtual reality. Getting experience although it's just simulated 3D world, is possibly, and I say possibly, important to understand things on a similar level as humans do, especially if the agent, or primarily if the agent needs to interact with the humans, right? If you talk about objects on top of each other in space and flying and cars and so on, and the agent has no experience with even virtual 3D worlds, it's probably hard to grasp.
So
but if we develop an abstract agent, say we take the mathematical path and we just want to build an agent which can prove theorems and becomes a better and better mathematician, then this agent needs to be able to reason in very abstract spaces, and then maybe sort of putting it into 3D environment, simulated or not, is even harmful. It should sort of, you put it in, I don't know, an environment which it creates itself or so.
do you think you can be good for the world or create an AGI system that's good when you're a for-profit company? From my perspective, I don't understand why profit interferes with positive impact on society. I don't understand why Google, that makes most of its money from ads, can't also do good for the world, or other companies, Facebook, anything. I don't understand why those have to interfere. You know, you can profit isn't the thing, in my view, that affects the impact of a company. What affects the impact of the company is the charter, is the culture, is the people inside, and profit is the thing that just fuels those people. So what are your views there?
Yeah, so I think it's a really good question, and there's some real like long-standing debates in human society that are wrapped up in it. The way that I think about it is just think about what are the most impactful nonprofits in the world? What are the most impactful for-profits in the world?
Right. It's much easier to list the for-profits.
That's right. And I think that there's some real truth here, that the system that we set up, the system for kind of how today's world is organized, is one that really allows for huge impact, and that kind of part of that is that you need to be for-profits are self-sustaining and able to kind of build on their own momentum. And I think that's a really powerful thing. It's something that, when it turns out that we haven't set the guardrails correctly, causes problems, right? Think about logging companies that go and deforest, the rainforest. That's really bad. We don't want that. And it's actually really interesting to me that kind of this question of how do you get positive benefits out of a for-profit company? It's actually very similar to how do you get positive benefits out of an AGI, right? That you have this like very powerful system. It's more powerful than any human, and is kind of autonomous in some ways. It's superhuman in a lot of axes, and somehow you have to set the guardrails to get good things to happen. But when you do, the benefits are massive. And so I think that when I think about nonprofit versus for-profit, I think just not enough happens in nonprofits. They're very pure, but it's just kind of, it's just hard to do things there. In for-profits in some ways, like too much happens. But if kind of shaped in the right way, it can actually be very positive. And so with OpenAI LP, we're picking a road in between. Now, the thing that I think is really important to recognize is that the way that we think about OpenAI LP is that in the world where AGI actually happens, right? In a world where we are successful, we build the most transformative technology ever, the amount of value we're going to create will be astronomical. Mm-hmm. And so then in that case, that the cap that we have will be a small fraction of the value we create. And the amount of value that goes back to investors and employees looks pretty similar to what would happen in a pretty successful startup. And that's really the case that we're optimizing for, right? That we're thinking about in the success case, making sure that the value we create doesn't get locked up. And I expect that in other for-profit companies that it's possible to do something like that. I think it's not obvious how to do it, right? And I think that as a for-profit company, you have a lot of fiduciary duty to your shareholders, and that there are certain decisions that you just cannot make. In our structure, we've set it up so that we have a fiduciary duty to the charter, right? That we always get to make the decision that is right for the charter, rather than, even if it comes at the expense of our own stakeholders. And so I think that when I think about what's really important, it's not really about nonprofit versus for-profit. It's really a question of, if you build AGI and you kind of, humanity is now in this new age, who benefits? Whose lives are better? And I think that what's really important is to have an answer that is everyone.
Yeah, which is one of the core aspects of the charter. So one concern people have, not just with OpenAI, but with Google, Facebook, Amazon, anybody really that's creating impact at scale, is how do we avoid, as your charter says, avoid enabling the use of AI or AGI to unduly concentrate power? Why would not a company like OpenAI keep all the power of an AGI system to itself?
The charter.
The charter. If you create an AGI system, like one that can ace the Turing test, natural language, what do you think would be the interactions you would have with it? What do you think are the questions you would ask? Like, what would be the first question you would ask? It, her, him.
That's right. I think that at that point, if you've really built a powerful system that is capable of shaping the future of humanity, the first question that you really should ask is, how do we make sure that this plays out well? And so that's actually the first question that I would ask a powerful AGI system is.
So you wouldn't ask your colleague, you wouldn't ask like Ilya, you would ask the AGI system.
Oh, we've already had the conversation with Ilya, right? And everyone here. And so you want as many perspectives and pieces of wisdom as you can for answering this question. So I don't think you necessarily defer to whatever your powerful system tells you, but you use it as one input to try to figure out what to do. But and I guess fundamentally, what it really comes down to is if you built something really powerful, and you think about, for example, the creation of shortly after the creation of nuclear weapons, right? The most important question in the world was, what's the world order going to be like? How do we set ourselves up in a place where we're going to be able to survive as a species? With AGI, I think the question is slightly different, right? That there is a question of how do we make sure that we don't get the negative effects? But there's also the positive side, right? You imagine that, like what will an AGI be like? Like what will it be capable of? And I think that one of the core reasons that an AGI can be powerful and transformative is actually due to technological development, right? If you have something that's capable as a human and that it's much more scalable, that you absolutely want that thing to go read the whole scientific literature and think about how to create cures for all the diseases, right? You want it to think about how to go and build technologies to help us create material abundance and to figure out societal problems that we have trouble with, like how are we supposed to clean up the environment? And, maybe you want this to go and invent a bunch of little robots that will go out and be biodegradable and turn ocean debris into harmless molecules. And I think that positive side is something that I think people miss sometimes when thinking about what an AGI will be like. And so I think that if you have a system that's capable of all of that, you absolutely want its advice about how do I make sure that we're using your capabilities in a positive way for humanity.
So what do you think about that? So do you share the intuition that some people have, from Sam Harris to even Elon Musk himself, that it's tricky as you develop AGI to keep it from slipping into the existential threats, into the negative? What's your intuition about how hard is it to keep AI development on the positive track? And what's your intuition there?
To answer that question, you can really look at how we structure OpenAI. So we really have three main arms. So we have capabilities, which is actually doing the technical work and pushing forward what these systems can do. There's safety, which is working on technical mechanisms to ensure that the systems we build are aligned with human values. And then there's policy, which is making sure that we have governance mechanisms, answering that question of, well, whose values? And so I think that the technical safety one is the one that people kind of talk about the most, right? You talk about, think about, all of the dystopic AI movies. A lot of that is about not having good technical safety in place. And what we've been finding is that, I think that actually a lot of people look at the technical safety problem and think it's just intractable, right? This question of what do humans want? How am I supposed to write that down? Can I even write down what I want? No way. And then they stop there. But the thing is, we've already built systems that are able to learn things that humans can't specify. Even the rules for how to recognize if there's a cat or a dog in an image. Right. Turns out it's intractable to write that down, and yet we're able to learn it. And that what we're seeing with systems we build at OpenAI, and they're still in early proof of concept stage, is that you are able to learn human preferences. You're able to learn what humans want from data. And so that's kind of the core focus for our technical safety team. And I think that we've had some pretty encouraging updates in terms of what we've been able to make work.
So you have an intuition and a hope that from data, looking at the value alignment problem, from data, we can build systems that align with the collective better angels of our nature. So align with the ethics and the morals of human beings.
To even say this in a different way, think about how do we align humans, right? Think about a human baby can grow up to be an evil person or a great person. And a lot of that is from learning from data, right? That you have some feedback as a child is growing up, they get to see positive examples. And so I think that just like the only example we have of a general intelligence that is able to learn from data to align with human values and to learn values, I think we shouldn't be surprised that we can do the same sorts of techniques, or whether the same sort of techniques end up being how we solve value alignment for AGIs.
So let's go even higher. I don't know if you read the book Sapiens, but do you think creating AGI, something or some new models, we would see echoes of the brilliance even at the prototype level? So you would be able to develop those ideas without scale, the initial seeds.
Well, so take a look at, I always like to look at examples that exist, right? Look at real precedent. And so take a look at the June 2018 model that we released, that we scaled up to turn into GPT-2. And you can see that at small scale, it set some records, right? This was, the original GPT. We actually had some cool generations. They weren't nearly as amazing and really stunning as the GPT-2 ones, but it was promising. It was interesting. And so I think it is the case that with a lot of these ideas that you see promise at small scale. But there is an asterisk here, a very big asterisk, which is sometimes we see behaviors that emerge that are qualitatively different from anything we saw at small scale. And that the original inventor of whatever algorithm looks at and says, I didn't think it could do that. This is what we saw in Dota, right? So PPO was created by John Cholmers, who's a researcher here. And with Dota, we basically just ran PPO at massive scale. And there's some tweaks in order to make it work, but fundamentally it's PPO at the core. And we were able to get this long-term planning, these behaviors to really play out on a time scale that we just thought was not possible. And John looked at that and was like, I didn't think it could do that. That's what happens when you're at 3 orders of magnitude more scale than you tested at.
Yeah, but it still has the same flavors of, at least echoes of the expected brilliance. Although I suspect with GPT scaled more and more, you might get surprising things. So yeah, you're right. It's interesting. It's difficult to see how far an idea will go when it's scaled. It's an open question.
Well, so to that point with Dota and PPO, here's a very concrete one, right? It's like, it's actually one thing that's very surprising about Dota that I think people don't really pay that much attention to is the degree of generalization out of distribution that happens, right? That you have this AI that's trained against other bots for its entirety, the entirety of its existence.
One of the interesting things in the charter is this idea that it'd be great if you could try to describe or untangle of switching from competition to collaboration in late stage AGI development. Yep. It's really interesting, this dance between competition and collaboration. How do you think about that?
Yeah. Assuming that you can actually do the technical side of AGI development, I think there's going to be 2 key problems with figuring out how do you actually deploy it and make it go well. The first one of these is the run up to building the first AGI. You look at how self-driving cars are being developed, and it's a competitive race. And the thing that always happens in a competitive race is that you have huge amounts of pressure to get rid of safety. And so that's one thing we're very concerned about, right? Is that multiple teams figuring out we can actually get there, but if we took the slower path that is more guaranteed to be safe, we will lose. And so we're going to take the fast path. And so the more that we can, both ourselves, be in a position where we don't generate that competitive race, where we say, if the race is being run and that, someone else is further ahead than we are, we're not going to try to leapfrog. We're going to actually work with them, right? We will help them succeed as long as what they're trying to do is to fulfill our mission, then we're good. We don't have to build AGI ourselves. And I think that's a really important commitment from us, but it can't just be unilateral, right? I think that it's really important that other players who are serious about building AGI make similar commitments. Right. And I think that, again, to the extent that everyone believes that AGI should be something to benefit everyone, then it actually really shouldn't matter which company builds it. And we should all be concerned about the case where we just race so hard to get there that something goes wrong.
So Oscar Wilde said, we're all in the gutter, but some of us are looking at the stars. And I think OpenAI has a charter that looks to the stars, I would say, to create intelligence, to create general intelligence, make it beneficial, safe, and collaborative. So can you tell me how that came about, how a mission like that and the path to creating a mission like that at OpenAI was founded?
Yeah. So I think that in some ways it really boils down to taking a look at the landscape, right? So if you think about the history of AI, that basically for the past 60 or 70 years, people have thought about this goal of what could happen if you could automate human intellectual labor.
Right.
Imagine you can build a computer system that could do that. what becomes possible. We have a lot of sci-fi that tells stories of various dystopias, and increasingly you have movies like Her that tell you a little bit about maybe more of a little bit utopic vision. You think about the impacts that we've seen from being able to have bicycles for our minds in computers, and that I think that the impact of computers and the internet has just far outstripped what anyone really could have predicted. And so I think that it's very clear that if you can build an AGI, it will be the most transformative technology that humans will ever create. And so what it boils down to then is a question of, well, is there a path? Is there hope? Is there a way to build such a system? And I think that for 60 or 70 years that people got excited and that ended up not being able to deliver on the hopes that people had pinned on them. And I think that then that after two winters of AI development, that people I think kind of almost stopped daring to dream, right? That really talking about AGI or thinking about AGI became almost this taboo in the community. Mm-hmm. But I actually think that people took the wrong lesson from AI history. And if you look back, starting in 1959 is when the perceptron was released. And this is basically, one of the earliest neural networks. It was released to what was perceived as this massive overhype. So in the New York Times in 1959, you have this article saying that, the perceptron will one day recognize people, call out their names, instantly translate speech between languages. Mm-hmm. And people at the time looked at this and said, this is like, your system can't do any of that, and basically spent 10 years trying to discredit the whole perceptron direction and succeeded. And all the funding dried up, and people kind of went in other directions. And in the 80s there was this resurgence, and I'd always heard that the resurgence in the 80s was due to the invention of backpropagation and these algorithms that got people excited. But actually the causality was due to people building larger computers. That you can find these articles from the 80s saying that the democratization of computing power suddenly meant that you could run these larger neural networks. And then people started to do all these amazing things. The backpropagation algorithm was invented. And that the neural nets people were running were these tiny little 20 neuron neural nets, right? Like, what are you supposed to learn with 20 neurons? Yeah. And so of course they weren't able to get great results. And it really wasn't until 2012 that this approach, that's almost the most simple, natural approach that people had come up with in the 50s, right? In some ways, even in the 40s, before there were computers, with the Pitts-McCulloch neuron, suddenly this became the best way of solving problems, right? And I think there are three core properties that deep learning has that I think are very worth paying attention to. The first is generality. We have a very small number of deep learning tools, SGD, deep neural net, maybe some RL, and it solves this huge variety of problems. Speech recognition, machine translation, game playing, all of these problems, small set of tools. So there's the generality. There's a second piece, which is the competence. You want to solve any of those problems? Throw out 40 years worth of normal computer vision research, replace it with a deep neural net. It's going to work better. And there's a third piece, which is the scalability, right? That one thing that has been shown time and time again is that if you have a larger neural network, throw more compute, more data at it, it will work better. Those three properties together feel like essential parts of building a general intelligence. Now, it doesn't just mean that if we scale up what we have, that we will have an AGI, right? There are clearly missing pieces. There are missing ideas. We need to have answers for reasoning. But I think that the core here is that for the first time, it feels that we have a paradigm that gives us hope that general intelligence can be achievable. And so as soon as you believe that, everything else comes into focus, right? If you imagine that you may be able to, and that the timeline I think remains uncertain, but I think that certainly within our lifetimes and possibly within a much shorter period of time than people would expect, if you can really build the most transformative technology that will ever exist, you stop thinking about yourself so much, right? And you start thinking about just like, how do you have a world where this goes well? And that you need to think about the practicalities of how do you build an organization and get together a bunch of people and resources, and to make sure that people feel motivated and ready to do it. But I think that then you start thinking about, well, what if we succeed? And how do we make sure that when we succeed, that the world is actually the place that we want ourselves to exist in, and almost in the Rawlsian Bale sense of the word. And so that's kind of the broader landscape. And OpenAI was really formed in 2015 with that high level picture of AGI might be possible sooner than people think, and that we need to try to do our best to make sure it's going to go well. And then we spent the next couple of years really trying to figure out, what does that mean? How do we do it? And, I think that typically with a company, you start out very small, so you and a co-founder, and you build a product, you get some users, you get product market fit. Then at some point you raise some money, you hire people, you scale, and then, down the road, then the big companies realize you exist and try to kill you. And for OpenAI, it was basically everything in exactly the opposite order.
Let me just pause for a second. You said a lot of things, and let me just admire the jarring aspect of what OpenAI stands for, which is daring to dream. I mean, you said it's pretty powerful. It caught me off guard because I think that's very true. The step of just daring to dream about the possibilities of creating intelligence in a positive and a safe way, but just even creating intelligence is a much needed, refreshing catalyst for the AI community. So that's the starting point. Okay, so then formation of OpenAI.
I would just say that when we were starting OpenAI, that kind of the first question that we had is it too late to start a lab with a bunch of the best people? Right?
Wow,
is that even
okay.
possible?
That was an actual question.
That was the core question of we had this dinner in July of 2015, and that was really what we spent the whole time talking about. And because you think about kind of where AI is that it had transitioned from being an academic pursuit to an industrial pursuit. Mm-hmm. And so a lot of the best people were in these big research labs, and that we wanted to start our own one that, no matter how much resources we could accumulate would be, pale in comparison to the big tech companies. And we knew that. And it was a question of, are we going to be actually able to get this thing off the ground? You need critical mass. You can't just do you and a co-founder build a product, right? You really need to have a group of, 5 to 10 people. And we kind of concluded it wasn't obviously impossible. So it seemed worth trying.
Well, you're also dreamers, so who knows, right?
That's right.
Okay, so speaking of that, competing with the big players, let's talk about some of the tricky things as you think through this process of growing, of seeing how you can develop these systems at scale that competes. That psychology that looks at all the different possible trajectories of an AGI system, many of which, perhaps the majority of which, are positive, and nevertheless focuses on the negative trajectories. I mean, you get to interact with folks, you get to think about this, maybe within yourself as well. You look at Sam Harris and so on. It seems to be, sorry to put it this way, but almost more fun to think about the negative possibilities. Whatever that's deep in our psychology. What do you think about that? And how do we deal with it? Because we want AI to help us.
So I think there's kind of two problems entailed in that question. The first is more of the question of, how can you even picture what a world with a new technology will be like? Now imagine we're in 1950 and I'm trying to describe Uber to someone.
Apps and the internet. Yeah, I mean, that's going to be extremely complicated, but it's imaginable.
It's imaginable, right? And now imagine being in 1950 and predicting Uber, right? And you need to describe the internet, you need to describe GPS, you need to describe the fact that everyone's going to have this phone in their pocket. And so I think that just the first truth is that it is hard to picture how a transformative technology will play out in the world. We've seen that before with technologies that are far less transformative than AGI will be. And so I think that one piece is that it's just even hard to imagine and to really put yourself in a world where you can predict what that positive vision would be like. And, I think the second thing is that I think it is always easier to support the negative side than the positive side. It's always easier to destroy than create. And less in a physical sense and more just in an intellectual sense, right? Because I think that with creating something, you need to just get a bunch of things right, and to destroy, you just need to get one thing wrong.
Yeah.
And so I think that what that means is that I think a lot of people's thinking dead ends as soon as they see the negative story. But that being said, I actually have some hope, right? I think that the positive vision is something that I think can be is something that we can talk about. And I think that just simply saying this fact of, like there's positive, there's negatives, everyone likes to dwell on the negative, people actually respond well to that message and say, you're right, there's a part of this that we're not talking about, not thinking about. And that's actually something that's I think really been a key part of how we think about AGI at OpenAI, right? You can kind of look at it as like, okay, like OpenAI talks about the fact that there are risks, and yet they're trying to build this system. Like, how do you square those two facts?
Do you think to create intelligence, general intelligence, you need one, consciousness, and two, a body? Do you think any of those elements are needed, or is intelligence something that's orthogonal to those?
I'll stick to the kind of like the non-grand answer first, right? So the non-grand answer is just to look at, what are we already making work? You look at GPT-2, a lot of people would have said that to even get these kinds of results, you need real world experience. You need a body, you need grounding. How are you supposed to reason about any of these things? How are you supposed to like even kind of know about smoke and fire and those things if you've never experienced them? Right. And GPT-2 shows that you can actually go way further than that kind of reasoning would predict. So I think that in terms of, do we need consciousness? Do we need a body? It seems the answer is probably not, right? That we could probably just continue to push kind of the systems we have. They already feel general. They're not as competent or as general or able to learn as quickly as an AGI would, but they're at least like kind of proto AGI in some way, and they don't need any of those things. Now let's move to the grand answer, which is, if our neural net's conscious already, would we ever know? How can we tell? Right? And here's where the speculation starts to become at least interesting or fun, and maybe a little bit disturbing, depending on where you take it. But it certainly seems that when we think about animals, that there's some continuum of consciousness. My cat, I think, is conscious in some way, right? Not as conscious as a human. And you could imagine that you could build like a little consciousness meter, right? You point at a cat, it gives you a little reading. Point at a human, it gives you a much bigger reading. What would happen if you pointed one of those at a dotted neural net? And if you're training in this massive simulation, do the neural nets feel pain? It becomes pretty hard to know that the answer is no. And it becomes pretty hard to really think about what that would mean if the answer were yes. And it's very possible, for example, you could imagine that maybe the reason that humans have consciousness is because it's a convenient computational shortcut, right? If you think about it, if you have a being that wants to avoid pain, which seems pretty important to survive in this environment, and wants to eat food, then that maybe the best way of doing it is to have a being that's conscious, right? Mm-hmm. That, in order to succeed in the environment, you need to have those properties, and how are you supposed to implement them? And maybe this consciousness is a way of doing that. If that's true, then actually maybe we should expect that really competent reinforcement learning agents will also have consciousness. But, it's a big if. And I think there are a lot of other arguments that you can make in other directions.
I think that's a really interesting idea that even GPT-2 has some degree of consciousness. That's something is actually not as crazy to think about. It's useful to think about as we think about what it means to create intelligence of a dog, intelligence of a cat, and the intelligence of a human. How far do you think, okay, this is where you kind of bring up the Elon Musk and the Sam Harris's, right? How far is your intuition about these kinds of self-play mechanisms being able to take us? Because it feels one of the ominous but stated calmly things that when I talked to David Silver, he said is that they have not yet discovered a ceiling for Alpha Zero, for example, on the game of Go or chess.
Oh, interesting.
It keeps, no matter how much the computer they throw at it, it keeps improving. So it's very possible that if you throw, some like 10x compute, that it will improve by 5x or something like that. And when stated calmly, it's so like, oh yeah, I guess so. But and then you think like, well, can we potentially have like continuations of Moore's law in totally different way, like broadly defined Moore's law,
right?
Not the
exponential improvement.
Exponential improvement, like. Are we going to have an Alpha Zero that swallows the world?
But notice it's not getting better at other things. It's getting better at Go.
Yeah.
And I think that's a big leap to say, okay, well, therefore it's better at other things.
Well, I mean, the question is how much of the game of life can be turned into.
Right. So that I think is a really good question. And I think that I don't think we as a, community really know the answer to this. But so I went to a talk by some experts on computer chess. So in particular, computer chess is really interesting because for 1,000 years, humans were the best chess playing things on the planet. And then computers like edged ahead of the best person. And they've been ahead ever since. It's not like people have overtaken computers. But computers and people together have overtaken computers.
Right.
So at least last time I checked, I don't know what the very latest is, but last time I checked that there were teams of people who could work with computer programs to defeat the best computer programs.
In the game of Go?
In the game of chess.
In the game of chess.
Right. And so using the information about how these things called ELO scores, this sort of notion of how strong a player are you. There's kind of a range of possible scores, and you increment in score. Basically, if you can beat another player of that lower score 62% of the time or something like that. Like there's some threshold of if you can somewhat consistently beat someone, then you are of a higher score than that person. And there's a question as to how many times can you do that in chess, right? And so we know that there's a range of human ability levels that cap out with the best playing humans. And the computers went a step beyond that. Mm-hmm. And computers and people together have not gone, I think, a full step beyond that. It feels, the estimates that they have is that it's starting to asymptote, that we've reached kind of the maximum, the best possible chess playing. And so that means that there's kind of a finite strategic depth, right? At some point, you just can't get any better at this game.
Yeah, I mean, I don't, so I'll actually check that. I think it's interesting because if you have somebody like Magnus Carlsen, who's using these chess programs to train his mind, like to learn
to
about
become
chess.
A better chess player, yeah.
And so, like, that's a very interesting thing because we're not static creatures. We're learning together. I mean, just like we're talking about social networks, those algorithms are teaching us just like we're teaching those algorithms. So that's a fascinating thing. But I think the best chess playing programs are now better than the pairs. Like they have competition between pairs, but it's still, even if they weren't, it's an interesting question. Where's the ceiling? So the ominous David Silver kind of statement is like, we have not found the ceiling.
Right. But so the question is, okay, so I don't know his analysis on that. From talking to Go experts, the strategic depth of Go seems to be substantially greater than that of chess, that there's more kind of steps of improvement that you can make, getting better and better and better and better. Yeah. But there's no reason to think that it's infinite.
Infinite, yeah.
And so it could be that it's that what David is seeing is a kind of asymptoting, that you can keep getting better, but with diminishing returns. And at some point, you hit optimal play. Like in theory, all these finite games, they're finite. They have an optimal strategy. There's a strategy that is the minimax optimal strategy. And so at that point, you can't get any better. You can't beat that strategy. Now, that strategy may be, from an information processing perspective, intractable, right? You need, all the situations are sufficiently different that you can't compress it at all. It's this giant mess of hard-coded rules, and we can never achieve that. But that still puts a cap on how many levels of improvement that we can actually make.
But the thing about self-play is if you put it, although I don't like doing that, in the broader category of self-supervised learning, is that it doesn't require too much or any human input.
Human labeling, yeah.
Yeah, human labeling or just human effort. The human involvement past a certain point. And the same thing you could argue is true for the recent breakthroughs in natural language processing with language models.
Oh, this is how you get to GPT-3.
Yeah, see how I did the...
that was a good transition. Yeah, you're a pro.
I practiced that for days leading up to this. No. But like that's one of the questions is, can we find ways to formulate problems in this world that are important to us humans, like more important than the game of chess, that to which self-supervised kinds of approaches could be applied, whether it's self-play, for example, for like maybe you could think of like autonomous vehicles in simulation, that kind of stuff, or just robotics applications in simulation, or in the self-supervised learning where unannotated data or data that's generated by humans naturally without extra cost, like the Wikipedia or like all of the internet, can be used to learn something about to create intelligent systems that do something really powerful, that pass the Turing test or that do some kind of superhuman level performance. So what's your intuition, like trying to stitch all of it together about our discussion of AGI, the limits of self-play, and your thoughts about maybe the limits of neural networks in the context of language models? Is there some intuition in there that might be useful to think about?
Yeah. So first of all, the whole transformer network family of things is really cool. It's really, really cool. I mean, if back in the day you played with, I don't know, Markov models for generating text, and you've seen the kind of text that they spit out, and you compare it to what's happening now, it's amazing. It's so amazing. Now, it doesn't take very long interacting with one of these systems before you find the holes, right? It's not smart in any kind of general way. It's really good at a bunch of things, and it does seem to understand a lot of the statistics of language extremely well. And that turns out to be very powerful. You can answer many questions with that. But it doesn't make it a good conversationalist, right? And it doesn't make it a good storyteller. It just makes it good at imitating of things it has seen in the past.
The exact same thing could be said by people who voting for Donald Trump about Joe Biden supporters, and people voting for Joe Biden about Donald Trump supporters. Is
that they're not intelligent. They're just following
they're following things they've seen in the past, and so it doesn't take long to find the flaws in their in their like natural language generation abilities.
Yes.
So we're being very
that's interesting
critical of AI systems.
Right. So I've had a similar thought, which was that the stories that GPT-3 spits out are amazing and very human-like. And it doesn't mean that computers are smarter than we realize necessarily. It partly means that people are dumber than we realize, or that much of what we do day to day is not that deep. Like we're just kind of going with the flow. We're saying whatever feels like the natural thing to say next. Not a lot of it is creative or meaningful or intentional. But enough is that we actually get by, right? We do come up with new ideas sometimes, and we do manage to talk each other into things sometimes, and we do sometimes vote for reasonable people sometimes. But it's really hard to see in the statistics because so much of what we're saying is kind of rote. Mm-hmm. And so our metrics that we use to measure how these systems are doing don't reveal that, because it's in the interstices that is very hard to detect.
But do you have an intuition that with these language models, if they grow in size, it's already surprising that when you go from GPT-2 to GPT-3, that there is a noticeable improvement. Yeah. So the question now goes back to the ominous David Silver and the ceiling.
Right. So maybe there's just no ceiling. We just need more compute. Now, I mean, okay, so now I'm speculating.
Yes.
As opposed to before when I was completely on firm ground.
Yeah.
All right. I don't believe that you can get something that really can do language and use language as a thing that doesn't interact with people. Like, I think that it's not enough to just take everything that we've said written down and just say, that's enough. You can just learn from that and you can be intelligent. I think you really need to be pushed back at. I think that conversations, even people who are pretty smart, maybe the smartest thing that we know, maybe not the smartest thing we can imagine, but we get so much benefit out of talking to each other and interacting. That's presumably why you have conversations live with guests, is that there's something in that interaction that would not be exposed by, oh, I'll just write you a story and then you can read it later. And I think because these systems are just learning from our stories, they're not learning from being pushed back at by us, that they're fundamentally limited into what they could actually become on this route. They have to get, shut down. We have to have an argument that they have to have an argument with us and lose a couple times before they start to realize, oh, okay, wait, there's some nuance here that actually matters.
Yeah, that's actually subtle sounding, but quite profound, that the interaction with humans is essential. And the limitation within that is profound as well, because the time scale, like the bandwidth at which you can really interact with humans is very low.
Yeah.
So it's costly. So you can't. One of the underlying things about self-play is it has to do, a very large number of interactions, and so you can't really deploy reinforcement learning systems into the real world to interact. Like you couldn't deploy a language model into the real world to interact with humans because it would just not get enough data relative to the cost it takes to interact. Like the time of humans is expensive, which is really interesting. That takes us back to reinforcement learning and trying to figure out if there's ways to make algorithms that are more efficient at learning, keep the spirit in reinforcement learning and become more efficient. In some sense, this seems to be the goal. I'd love to hear what you're known for not sugarcoating your opinions and speaking your mind about ideas in AI, especially on Twitter. It's one of my favorite Twitter accounts. So what's one of the more controversial ideas you've expressed online and gotten some heat for? How do you pick?
How do I pick? Yeah, no, I think if you have, if you go through the trouble of maintaining a Twitter account, you might as well speak your mind, Otherwise, what's even the point of having a Twitter account? It's like having a nice car and just leave it in the garage. So what's one thing for which I got a lot of pushback? Perhaps, that time I wrote something about the idea of intelligence explosion. And I was questioning the idea and the reasoning behind this idea. And I got a lot of pushback on that. I got a lot of flack for it. So intelligence explosion, I'm sure you're familiar with the idea, but it's the idea that if you were to build general AI problem-solving algorithms, well, the problem of building such an AI, that itself is a problem that could be solved by your AI, and maybe it could be solved better than what humans can do. Right. So your AI could start tweaking its own algorithm, could start making a better version of itself, and so on iteratively in a recursive fashion. And so you would end up with an AI with exponentially increasing intelligence.
That's right.
And I was basically questioning this idea, first of all, because the notion of intelligence explosion uses an implicit definition of intelligence that doesn't sound quite right to me. It considers intelligence as a property of a brain that you can consider in isolation, like the height of a building, for instance.
Right.
But that's not really what intelligence is. Intelligence emerges from the interaction between a brain, a body, like embodied intelligence, and an environment. And if you're missing one of these pieces, then you cannot really define intelligence anymore. So just tweaking a brain to make it smarter and smarter doesn't actually make any sense to me.
So first of all, you're crushing the dreams of many people, right? So there's let's look at like Sam Harris, actually a lot of physicists, Max Tegmark, people who think, the universe is an information processing system. Our brain is kind of an information processing system. So what's the theoretical limit? Like, it doesn't make sense that there should be some, it seems naive to think that our own brain is somehow the limit of the capabilities of this information. I'm playing devil's advocate here, this information processing system. And then if you just scale it, if you're able to build something that's on par with the brain, the process that builds it just continues and it'll improve exponentially. So that's the logic that's used actually by almost everybody that is worried about superhuman intelligence.
Yeah.
So you're trying to make, so most people who are skeptical of that are kind of like, their thought process, this doesn't feel right. Like that's for me as well. So I'm more like, the whole thing is shrouded in mystery where you can't really say anything concrete, but you could say this doesn't feel right. This doesn't feel like that's how the brain works. And you're trying to, with your blog post and now making it a little more explicit. So one idea is that the brain doesn't exist alone. It exists within the environment. So you can't you would have to somehow exponentially improve the environment and the brain together. Almost, in order to create something that's much smarter. in some kind of course, we don't have a definition of intelligence.
That's correct. That's correct. I don't think, if you look at very smart people today, even humans, not even talking about AIs, I don't think their brain and the performance of their brain is the bottleneck to their expressed intelligence, to their achievements. You cannot just tweak one part of this system, like of this brain, body, environment system, and expect the capabilities, like what emerges out of this system, to just, explode exponentially. Because anytime you improve one part of a system with many interdependencies like this, there's a new bottleneck that arises, right? And I don't think even today, for very smart people, their brain is not the bottleneck to the sort of problems they can solve, right? In fact, many very, very smart people today, they're not actually solving any big scientific problems. They're not Einstein. They're like Einstein, but, the patent clerk days. Like Einstein became Einstein because this was a meeting of a genius with a big problem at the right time, right? But maybe this meeting could have never happened, and then Einstein would have just been a patent clerk, right? And in fact, many people today are probably like genius level smart, but you wouldn't know because they're not really expressing any of that.
Wow, that's brilliant. So we can think of the world, Earth, but also the universe as a space of problems. So all these problems and tasks are roaming it of various difficulty. And there's agents, creatures like ourselves and animals and so on that are also roaming it. And then you get coupled with a problem and then you solve it. But without that coupling, you can't demonstrate your quote unquote intelligence.
Exactly. Intelligence is the meeting of great problem solving capabilities with a great problem. And if you don't have the problem, you don't really express any intelligence. All you're left with is potential intelligence, like the performance of your brain or, how high your IQ is, which in itself is just a number, right?
So you mentioned problem solving capacity.
Yeah.
What do you think of as problem solving capacity? Does the possibility of creating an AGI system excite you or scare you or bore you?
So intelligence can never really be general. At best, it can have some degree of generality, like human intelligence. It also always has some specialization in the same way that human intelligence is specialized in a certain category of problems, is specialized in the human experience. And when people talk about AGI, I'm never quite sure if they're talking about very, very smart AI, so smart that it's even smarter than humans, or they're talking about human-like intelligence, because these are different things.
Let's say, presumably, I'm impressing you today with my humanness. So imagine that I was in fact a robot. So what does that mean? I'm impressing you with natural language processing. Maybe if you weren't able to see me, maybe this is a phone call. Yeah. So that kind of system.
Okay, so
companion.
So that's very much about building human-like AI. And you're asking me, is this an exciting perspective?
Yes.
I think so, yes. Not so much because of what artificial human-like intelligence could do, but from an intellectual perspective, I think if you could build truly human-like intelligence, that means you could actually understand human intelligence, which is fascinating, right? Human-like intelligence is going to require emotions. It's going to require consciousness, which is not things that would normally be required by an intelligent system. If you look at, we were mentioning earlier, like science as a superhuman problem-solving agent or system, it does not have consciousness, it doesn't have emotions. In general, so emotions, I see consciousness as being on the same spectrum as emotions. It is a component of the subjective experience that is meant very much to guide behavior generation, right? Mm-hmm. It's meant to guide your behavior. In general, human intelligence and animal intelligence has evolved for the purpose of behavior generation, right? Mm-hmm. Including in a social context. So that's why we actually need emotions. That's why we need consciousness. An artificial intelligence system developed in a different context may well never need them, may well never be conscious, like science.
On that point, I would argue it's possible to imagine that there's echoes of consciousness in science when viewed as an organism, that science is consciousness.
So, I mean, how would you go about testing this hypothesis? How do you probe the subjective experience of an abstract system like science?
Well, the point of probing any subjective experience is impossible because I'm not science, I'm Lex. So I can't probe another entities, it's no more than bacteria on my skin.
Your Lex, I can ask you questions about your subjective experience and you can answer me. And that's how I know you're conscious.
Yes, but that's because we speak the same language. We have to speak the language of science in order to ask.
Honestly, I don't think consciousness, just like emotions or pain and pleasure, is not something that inevitably arises from any sort of sufficiently intelligent information processing. It is a feature of the mind. And if you've not implemented it explicitly, it is not there.
So you think it's an emergent feature of a particular architecture. So do you think
it's a feature in the same sense? So again, the subjective experience is all about guiding behavior. If the problems you're trying to solve don't really involve embodied agent, maybe in a social context, generating behavior and pursuing goals like this. And if you look at science, that's not really what's happening, even though it is a form of artificial AI in this artificial intelligence, in the sense that it is solving problems, it is accumulating knowledge, accumulating solutions, and so on. So if you're not explicitly implementing a subjective experience, implementing certain emotions and implementing consciousness, it's not going to just spontaneously emerge.
Yeah, but so this is a place that, again, maybe taking a slight step outside, we're philosophizing a little bit. Let me ask you about human level or superhuman level intelligence, the artificial intelligence systems. What do you make from almost a religious or a perspective that we've been talking about of the special aspect of human nature, of us creating intelligence systems that exhibit some elements of that human nature? Is that something, again, like we were talking about with transhumanism, there's a feasibility question of how hard is it to actually build machines that are human level intelligence or have something like consciousness or have all those kinds of human qualities. And then there's do we want to do that kind of thing? So on both of those directions, what do you think?
Well, okay. So, since your podcast is called AI, I don't want to offend too many of your listeners out there. But I think one should be a little bit more modest about one's claims for AI than have typically been the case.
Yeah.
I think that actually a lot of people in AI are somewhat chastened, and so there are more modest claims than are common with the transhumanists and so forth. And, I used to play chess when I was a kid. I was pretty good at it, okay? Won competitions and so on and so forth. And I'm talking about when I was in high school, I thought it was pretty unlikely that a computer would be able to become good at chess. But I was dead wrong, okay? And so,
how did that make you feel, by the way, when T Blue Big Kasparov?
I stopped playing chess seriously when I encountered computers that could beat me. Okay,
Yeah.
I still play with my grandchildren a little bit, but yeah, it seemed like, in a certain sense, it became a solved problem when AI was able to do it better than I could. So I think that there are ways in which today we've seen computers do things which historically were regarded as being very characteristic of human intelligence. And in that sense, there is some success to AI. I also think that, there are certain things which one might think of as being AI, which are, completely widespread in our society. I'm thinking about the internet, search engines, and so forth, which are enormously influential and obviously do things more powerfully than any individual human or even any combination of humans could do, much faster and accessing databases and so on and so forth. All of this is outstripped our human intelligence. I'm not sure the extent, though, to which that is really intelligence in the way that was traditionally meant, but it's certainly amazingly facile, and it multiplies our ability to access human knowledge and data and so forth. So,
is that something? Is that enter the realm of something we should be concerned about? So, in the realm of religion, you talk about what is good, what is evil, what is right, what is wrong. You have a set of morals, set of beliefs, and when you have an entity come into the picture that has quite a bit of power, if we potentially look into the future, and intelligence and capability, do you think there's something that religion can say about artificial intelligence, or is that something we shouldn't worry about until it arrives, you think? Just like with the chess program.
Religious writers have thought about this for centuries. There's been a long debate about what was historically called a plurality of worlds. And it was actually more about whether there are places where other intelligent creatures live than it was about us creating them. But I think it's largely the same question.
It's almost like aliens, like other intelligent life.
So if there is other intelligent life in the universe, what is its relationship to God? Okay, that is, in a certain sense, the puzzle that religious thinkers and writers have thought about for a long time. And there's a whole range of different opinions about that. I mean, personally, I think it's an interesting question, but it's not a very pressing question at the moment. And I think the same way about the question of what happens if we're able to build a sentient robot, for example. I think it's an interesting question, and we'll have to think about it when that happens. But I think we're still quite a ways away from that. And so I don't have a good answer. But I think there's a literature that one could tap to think about. Okay.
If you want to start early on the question. Yeah. Well, let me ask. So there's a guy named Alan Turing, came up with a Turing test.
Yeah.
What do you think is a good test of intelligence? Perhaps we're drifting in a topic that we're maybe philosophizing about, but what do you think is a good test for intelligence for an artificial intelligence system?
Well, the standard definition of artificial general intelligence is that it can do anything that people can do, and it can do them better.
Yes.
What we are seeing is that in many domains, you have domain-specific and devices or programs or software, and they beat people easily in specified way. What we are very far from is that general ability, a general purpose intelligence. So in machine learning, people are approaching something more general. I mean, for AlphaZero was much more general than AlphaGo, but it's still extraordinarily narrow and specific in what it can do. So we're quite far from something that can, in every domain, think like a human except better.
What aspect? So the Turing test has been criticized as natural language conversation.
Yeah.
That it's too simplistic. It's easy to quote unquote pass under constraints specified. What aspect of conversation would impress you if you heard it? Is it humor? Is it what would impress the heck out of you if you saw it in conversation?
Yeah, I mean, certainly wit would be impressive, and humor would be more impressive than just factual conversation, which I think is easy, and allusions would be interesting, and metaphors would be interesting. I mean, but new metaphors, not practiced metaphors. So there is a lot that, would be sort of impressive if that is completely natural in conversation, but that you really wouldn't expect.
Does the possibility of creating a human level intelligence or superhuman level intelligence system excite you, scare you?
Well, I mean,
How does it make you feel?
I find the whole thing fascinating, absolutely fascinating.
So exciting.
I think, and exciting. It's also terrifying, but I'm not going to be around to see it. And so I'm curious about what is happening now. But I also know that predictions about it are silly. We really have no idea what it will look like 30 years from now. No idea.
What do you think it takes to, let's talk about AGI a little bit. What do you think it takes to build a system of human level intelligence? We talked about reasoning, we talked about long-term memory, but in general, what does it take, do you think?
Well, I can't be sure, but I think that deep learning plus maybe another small idea.
Do you think self-play will be involved? Sort of like you've spoken about the powerful mechanism of self-play where systems learn by sort of exploring the world in a competitive setting against other entities that are similarly skilled as them, and so incrementally improve in this way. Do you think self-play will be a component of building an AGI system?
Yeah. So what I would say to build AGI, I think it's going to be deep learning plus some ideas. And I think self-play will be one of those ideas. I think that is a very... Self-play has this amazing property that it can surprise us in truly novel ways. For example, pretty much every self-play system, both our DotaBot, I don't know if OpenAI had a release about multi-agent where you had two little agents who were playing hide and seek. Mm-hmm. And of course also AlphaZero. They were all produce surprising behaviors. They all produce behaviors that we didn't expect. They are creative solutions to problems. And that seems like an important part of AGI that our systems don't exhibit routinely right now. And so that's why I like this area. I like this direction because of its ability to surprise us.
And AGI system would surprise us fundamentally.
Yes, and to be precise, not just a random surprise, but to find a surprising solution to a problem that's also useful.
Right. Now, a lot of the self-play mechanisms have been used in the game context, or at least in the simulation context. How far along the path to AGI do you think will be done in simulation? How much faith, promise do you have in simulation versus having to have a system that operates in the real world, whether it's the real world of digital real world data or real world like actual physical world with robotics?
I don't think it's an either or. I think simulation is a tool and it helps. It has certain strengths and certain weaknesses and we should use it.
Yeah, but okay, I understand that. That's true. But one of the criticisms of self-play, one of the criticisms of reinforcement learning is one of its current power, its current results, while amazing, have been demonstrated in simulated environments or very constrained physical environments. Do you think it's possible to escape them? Escape the simulated environments and be able to learn in non-simulated environments? Or do you think it's possible to also just simulate in a photorealistic and physics realistic way the real world in a way that we can solve real problems with self-play in simulation?
So I think that transfer from simulation to the real world is definitely possible and has been exhibited many times by many different groups. It's been especially successful in vision. Also, OpenAI in the summer has demonstrated a robot hand which was trained entirely in simulation in a certain way that allowed for sim to real transfer to occur.
Is this for the Rubik's Cube?
Yeah, that's right. And so
I wasn't aware that was trained in simulation.
It was trained in simulation entirely.
Really? So it wasn't in the physical, the hand wasn't trained?
No. 100% of the training was done in simulation. And the policy that was learned in simulation was trained to be very adaptive. So adaptive that when you transfer it, it could very quickly adapt to the physical world.
So the kind of perturbations with the giraffe or whatever the heck it was, were those part of the simulation?
Well, the simulation was generally, so the simulation was trained to be robust to many different things, but not the kind of perturbations we've had in the video. So it's never been trained with a glove. It's never been trained with a stuffed giraffe.
So in theory, these are novel perturbations.
Correct. It's not in theory, in practice.
That those are novel perturbations. Well, that's okay. That's a clean, small scale but clean example of a transfer from the simulated world to the physical world.
Yeah, and I will also say that I expect the transfer capabilities of deep learning to increase in general, and the better the transfer capabilities are, the more useful simulation will become. Because then you could experience something in simulation and then learn a moral of the story, which you could then carry with you to the real world.
Right.
As humans do all the time when they play computer games.
So let me ask sort of an embodied question, staying on AGI for a sec. Do you think AGI system would need to have a body? Would need to have some of those human elements of self-awareness, consciousness, sort of fear of mortality, sort of self-preservation in the physical space, which comes with having a body?
I think having a body will be useful. I don't think it's necessary. But I think it's very useful to have a body for sure, because you can learn a whole new... You can learn things which cannot be learned without a body. But at the same time, I think that you can, if you don't have a body, you could compensate for it and still succeed.
You think so?
Yes. Well, there is evidence for this. For example, there are many people who were born deaf and blind, and they were able to compensate for the lack of modalities. I'm thinking about Helen Keller specifically.
So even if you're not able to physically interact with the world, and if you're not able to... I mean, I actually was getting at... Maybe let me ask on the more particular... I'm not sure if it's connected to having a body or not, but the idea of consciousness, and a more constrained version of that is self-awareness. Do you think an AGI system should have consciousness? It's what we can't define, whatever the heck you think consciousness is.
Yeah, hard question to answer, given how hard it is to define it.
Do you think it's useful to think about?
I mean, it's definitely interesting. It's fascinating. I think it's definitely possible that our systems will be conscious.
Do you think that's an emergent thing that just comes from... Do you think consciousness could emerge from the representation that's stored within neural networks? So like that, it naturally just emerges when you become more and more... You're able to represent more and more of the world?
Well, I'd make the following argument, which is humans are conscious, and if you believe that artificial neural nets are sufficiently similar to the brain, then there should at least exist artificial neural nets that should be conscious too.
You're leaning on that existence proof pretty heavily. Okay.
But that's the best answer I can give.
No, I know. There's still an open question if there's not some magic in the brain that we're not. I mean, I don't mean a non-materialistic magic, but that the brain might be a lot more complicated and interesting than we give it credit for.
If that's the case, then it should show up, and at some point we will find out that we can't continue to make progress. But I think it's unlikely.
So we talk about consciousness, but let me talk about another poorly defined concept of intelligence. Again, we've talked about reasoning. We've talked about memory. What do you think is a good test of intelligence for you? Are you impressed by the test that Alan Turing formulated with the imitation game with natural language? Is there something in your mind that you would be deeply impressed by if a system was able to do?
I mean, lots of things. There is a certain frontier of capabilities today.
Yes.
And there exist things outside of that frontier. And I would be impressed by any such thing. Like, for example, I would be impressed by a deep learning system which solves a very pedestrian task like machine translation or computer vision task or something which never makes mistake a human wouldn't make under any circumstances. I think that is something which have not yet been demonstrated, and I would find it very impressive.
Yeah, so right now they make mistakes they might be more accurate than human beings, but they make a different set of mistakes.
So I would guess that a lot of the skepticism that some people have about deep learning is when they look at their mistakes and they say, well, those mistakes, they make no sense. Like if you understood the concept, you wouldn't make that mistake.
Yes.
And I think that changing that would inspire me. That would be, yes, this is progress.
Yeah, that's a really nice way to put it. But I also just don't like that human instinct to criticize a model as not intelligent. That's the same instinct as we do when we criticize any group of creatures as the other. Because it's very possible that GPT-2 is much smarter than human beings at many things.
That's definitely true. It has a lot more breadth of knowledge.
Yes, breadth of knowledge, and even perhaps depth on certain topics.
It's kind of hard to judge what depth means, but there's definitely a sense in which humans don't make mistakes that these models do.
Yes. The same is applied to autonomous vehicles. The same is probably going to continue being applied to a lot of artificial intelligence systems. We find this is the annoying thing. This is the process of, in the 21st century, the process of analyzing the progress of AI is the search for one case where the system fails in a big way where humans would not. And then many people writing articles about it. And then broadly the public generally gets convinced that the system is not intelligent. And we like pacify ourselves by thinking it's not intelligent because of this one anecdotal case. And this seems to continue happening.
Yeah, I mean, there is truth to that. Although I'm sure that plenty of people are also extremely impressed by the systems that exist today. But I think this connects to the earlier point we discussed, that it's just confusing to judge progress in AI.
Yeah.
And, you have a new robot demonstrating something. How impressed should you be? And I think that people will start to be impressed once AI starts to really move the needle on the GDP.
So you're one of the people that might be able to create an AGI system here. Not you, but you and OpenAI. If you do create an AGI system and you get to spend sort of the evening with it, him, her, what would you talk about, do you think?
The very first time?
First time.
Well, the first time I would just ask all kinds of questions and try to get it to make a mistake, and I would be amazed that it doesn't make mistakes, and I just keep asking broad questions.
What kind of questions do you think? Would they be factual, or would they be personal, emotional, psychological? What do you think?
All of the above.
Would you ask for advice?
Definitely. I mean, why would I limit myself
Yeah.
talking to a system like this?
Now, again, let me emphasize the fact that you truly are one of the people that might be in the room where this happens. So let me ask a sort of a profound question about, I've just talked to a Stalin historian. I've been talking to a lot of people who are studying power. Abraham Lincoln said, "Nearly all men can stand adversity, but if you want to test a man's character, give him power." I would say the power of the 21st century, maybe the 22nd, but hopefully the 21st, would be the creation of an AGI system and the people who have control, direct possession and control of the AGI system. So what do you think, after spending that evening having a discussion with the AGI system, what do you think you would do?
Well, the ideal world I'd like to imagine is one where humanity are like the board members of a company where the AGI is the CEO. So it would be, I would like, the picture which I would imagine is you have some kind of different entities, different countries or cities, and the people that live there vote for what the AGI that represents them should do, and then the AGI that represents them goes and does it. I think a picture like that I find very appealing. And you could have multiple AGI. You would have an AGI for a city, for a country, and it would be trying to, in effect, take the democratic process to the next level.
And the board can always fire the CEO.
Essentially, press the reset button, say.
Press the reset.
Re-randomize the parameters.
But let me sort of, that's actually, okay, that's a beautiful vision, I think, as long as it's possible to to press the reset button. Do you think it will always be possible to press the reset button?
So I think that it's definitely will be possible to build. So you're talking. So the question that I really understand from you is, will humans or humans, people have control over the AI systems that they build?
Yes.
And my answer is, it's definitely possible to build AI systems which will want to be controlled by their humans.
Wow, that's part of their. So it's not that just they can't help but be controlled, but they exist. One of the objectives of their existence is to be controlled.
In the same way that human parents generally want to help their children, they want their children to succeed. It's not a burden for them. They are excited to help the children and to feed them and to dress them and to take care of them. And I believe, with high conviction, that the same will be possible for an AGI. It will be possible to program an AGI, to design it in such a way that it will have a similar deep drive that it will be delighted to fulfill. And the drive will be to help humans flourish.
But let me take a step back to that moment where you create the AGI system. I think this is a really crucial moment. And between that moment and the democratic board members with the AGI at the head, there has to be a relinquishing of power. So as George Washington, despite all the bad things he did, one of the big things he did is he relinquished power. He, first of all, didn't want to be president. And even when he became president, he didn't keep just serving as most dictators do for indefinitely. Do you see yourself being able to relinquish control over an AGI system, given how much power you can have over the world? At first, financial, just make a lot of money, right? And then control by having possession of this AGI system.
I'd find it trivial to do that. I'd find it trivial to relinquish this kind of power. I mean, the kind of scenario you are describing sounds terrifying to me. That's all. I would absolutely not want to be in that position.
Do you think you represent the majority or the minority of people in the AI community?
Well, I mean,
it's an open question, an important one. Are most people good is another way to ask it.
So I don't know if most people are good, but I think that when it really counts, people can be better than we think.
That's beautifully put. Yeah. Are there specific mechanisms you can think of aligning AI agent values to human values? Do you think about these problems of continued alignment as we develop the AI systems?
Yeah, definitely. In some sense, the kind of question which you are asking is, so if I were to translate the question to today's terms,
yes,
it would be a question about how to get an RL agent that's optimizing a value function which itself is learned. And if you look at humans are like that because the reward function, the value function of humans is not external, it is internal.
That's right.
And there are definite ideas of how to train a value function, basically an objective, an as objective as possible perception system that will be trained separately to recognize, to internalize human judgments on different situations. And then that component would then be integrated as the base value function for some more capable RL system. You could imagine a process like this. I'm not saying this is the process. I'm saying this is an example of the kind of thing you could do.
You've kind of alluded that you don't have to have consciousness for high levels of intelligence, but to create truly general intelligence systems, AGI systems at human level intelligence and perhaps superhuman level intelligence, you've talked about that you feel like that kind of thing might be very far away, but nevertheless, when we reach that point, do you think consciousness from an engineering perspective is needed, or at least highly beneficial for creating an AGI system?
Yeah, no one knows what consciousness is for functionally. So right now, there's no specific thing we can point to and say, you need consciousness for that. Still, my inclination is to believe that, in principle, AGI is possible. At the very least, I don't see why someone couldn't simulate a brain, ultimately have a computational system that produces all of our behavior. And if that's possible, I'm sure vastly many other computational systems of equal or greater sophistication are possible with all of our cognitive functions and more. And my inclination is to think that once you've got all these cognitive functions, perception, attention, reasoning, introspection, language, emotion, and so on, it's very likely you'll have consciousness as well. At least it's very hard for me to see how you'd have a system that had all those things while bypassing somehow consciousness.
So just naturally, it's integrated quite naturally. There's a lot of overlap about the kind of function that required to achieve each of those things. So you can't disentangle them even when you're recreating.
At least in us, but we don't know what the causal role of consciousness in the physical world, what it does. I mean, just say it turns out consciousness does something very specific in the physical world, like collapsing wave functions, as on one common interpretation of quantum mechanics. Then ultimately we might find some place where it actually makes a difference. And we could say, here is where in collapsing wave functions, it's driving the behavior of a system. And maybe it could even turn out that for AGI, you'd need something playing that. I mean, if you wanted to connect this to free will, some people think consciousness collapsing wave functions. That would be how the conscious mind exerts effect on the physical world and exerts its free will. And maybe it could turn out that any AGI that didn't utilize that mechanism would be limited in the kinds of functionality that it had. I don't myself find that plausible. I think probably that functionality could be simulated. But you could imagine once we had a very specific idea about the role of consciousness in the physical world, this would have some impact on the capacity of AGIs. And if it was a role that could not be duplicated elsewhere, then we'd have to find some way to either get consciousness in the system to play that role or to simulate it.
If we can isolate a particular role to consciousness, of course, that's incredibly, seems like an incredibly difficult thing. Do you have worries about existential threats of conscious, intelligent beings that are not us? So certainly, I'm sure you're worried about us.
Yeah.
From an existential threat perspective, but outside of us, AI systems.
There's a couple of different kinds of existential threats here. One is an existential threat to consciousness generally. I mean, yes, I care about humans and the survival of humans and so on, but just say it turns out that eventually we're replaced by some artificial beings that aren't humans, but are somehow our successors. They still have good lives. They still do interesting and wonderful things with the universe. I don't think that's not so bad. That's just our successors. We were one stage in evolution. Something different, maybe better, came next. If, on the other hand, all of consciousness was wiped out, that would be a very serious moral disaster. One way that could happen is by all intelligent life being wiped out. And many people think that, once you get to humans and AIs and amazing sophistication where everyone has got the ability to create weapons that can destroy the whole universe just by pressing a button, then maybe it's inevitable all intelligent life will die out. That would certainly be a disaster, and we've got to think very hard about how to avoid that. But another interesting kind of disaster is that maybe intelligent life is not wiped out, but all consciousness is wiped out. So just say you thought, unlike what I was saying a moment ago, that there are two different kinds of intelligent systems, some which are conscious and some which are not. And just say it turns out that we create AGI with high degree of intelligence, meaning high degree of sophistication in its behavior, but with no consciousness at all. That AGI could take over the world, maybe, but then there'd be no consciousness in this world. This would be a world of zombies. Some people have called this the zombie apocalypse. Because it's an apocalypse for consciousness. Consciousness is gone. You've merely got this super intelligent, non-conscious robots. And I would say that's a moral disaster in the same way. In almost the same way that the world with no intelligent life is a moral disaster. All value and meaning may be gone from that world. So these are both threats to watch out for. Now, my own view is if you get super intelligence, you're almost certainly going to bring consciousness with it. So I hope that's not going to happen. But of course, I don't understand consciousness. No one understands consciousness. This is one reason, at least among many, for thinking very seriously about consciousness and thinking about the kind of future we want to create with in a world with humans and or AIs.
How do you feel about the possibility, if consciousness so naturally does come with AGI systems, that we are just a step in the evolution, that we will be just something, a blimp on the record that'll be studied in books by the AGI systems centuries from now?
I mean, I think I'd probably be okay with that, especially if somehow humans are continuous with AGIs. I mean, I think something like this is inevitable. At the very least, humans are going to be transformed. We're going to be augmented by technology. It's already happening in all kinds of ways. We're going to be transformed by technology, where our brains are going to be uploaded and computationally enhanced. And eventually that line between what's a human and what's an AI may be kind of hard to draw. How much does it matter, for example, that some future being 1,000 years from now that somehow descended from us actually still has biology? I think it would be nice if you could kind of point to its cognitive system, point to some parts that had some roots in us and trace a continuous line there. That would be selfishly nice for me to think that, okay, I'm connected to this thread line through the future of the world. But if it turns out, okay, there's a jump there. They found a better way to design cognitive systems. They designed a wholly new kind of thing, and the only line is some causal chain of designing and systems that design better systems. Is that so much worse? I don't know. We're still at least part of a causal chain of design, and yes, they're not humans, but still they're our successors. So, I mean, ultimately, I think it's probably inevitable that something like that will happen, and at least we were part of the process. It'd be nice if they still cared enough about us to, maybe to engage with our arguments. And maybe, I'm really hoping that the AGIs are going to solve all the problems of philosophy. Right. They'll come back and read all this crappy work from the 20th and 21st century, hard problem of consciousness, and here is why they got it wrong. And so on. If that happened, then I'd really feel like I was part of at least an intellectual process over centuries, and that would be kind of cool.
Well, I'm pretty sure they would clone or they would recreate David Chalmers and for the fun of it, sort of bring back other philosophers.
Yeah, bring back Descartes.
And just put them in a room and just watch. It'll be a Netflix of the future show where you bring philosophers from different 100% human philosophers from previous generations, put them in a room and see them.
I am totally up for that. Simulators, AGIs of the future. If you're watching this podcast, do that. I would like to be recreated. And,
who would be
Descartes?
Descartes would be the first. Who if you could hang out as part of such a TV show with a philosopher that's no longer with us from long ago, who would you choose?
Well, Descartes would have to be right up there. Oh, actually, a couple of months ago, I got to have a conversation with Descartes. An actor who's actually a philosopher came out on stage playing Descartes. I didn't know this was going to happen. And just after I gave a talk, and
a bit of a
told me
surreal
about
moment.
how my ideas were crap and all derived from him and so on. We had a long argument. This was great. I would love to see what Descartes would think about AI, for example, and the modern neuroscience and so on. I suspect not too much would surprise him, but William James. For a psychologist of consciousness, I think James was probably the richest. But there are Immanuel Kant. I never really understood what he was up to. If I got to actually talk to him about some of this, hey, there was Princess Elizabeth who talked with Descartes and who really got at the problems of how Descartes' ideas of a non-physical mind interacting with the physical body couldn't really work. She's been most philosophers think she's been proved right. So maybe put me in a room with Descartes and Princess Elizabeth, and we can all argue it out.
You believe, as many do, that we're far from creating an artificial general intelligence system. But say, once we do, and you get to ask her one question, what would that question be?
what is it that differentiates you and me?
Beautifully put. Kai-Fu, thank you so much for your time today. That was
Thank you.
wonderful. So another existential risk comes from the mysterious, the beautiful artificial intelligence.
Yeah.
So what's the shape of your concerns about AI?
I think there are quite a lot of concerns about AI, and sometimes the different risks don't get distinguished enough. So the kind of classic worry, most is closely associated with Nick Bostrom and Ilya Sutskever, is that we at some point move from having narrow AI systems to artificial general intelligence. You get this very fast feedback effect where AGI is able to artificial intelligence helps you to build greater artificial intelligence. We have this one system that's suddenly very powerful, far more powerful than others, perhaps far more powerful than, the rest of the world combined. And then secondly, it has goals that are misaligned with human goals. Mm-hmm. And so it pursues its own goals. It realizes, hey, there's this competition, namely from humans. It would be better if we eliminated them. In just the same way as Homo sapiens eradicated the Neanderthals. In fact, killed off most large animals on the planet that walk the planet. So that's kind of one set of worries. I think that's not I think these shouldn't be dismissed as science fiction. I think it's something we should be taking very seriously.
But it's not the thing you visualize when you're concerned about the biggest near term.
Yeah, I think it's like one possible scenario that would be astronomically bad. I think there are other scenarios that would also be extremely bad, comparably bad, that are more likely to occur. So one is just we are able to control AI, so we're able to get it to do what we want it to do. And perhaps there's not like this fast takeoff of AI capabilities within a single system. It's distributed across many systems that do somewhat different things. But you do get very rapid economic and technological progress as a result. That concentrates power into the hands of a very small number of individuals, perhaps a single dictator. And secondly, that single individual or small group of individuals or single country is then able to lock in their values indefinitely via transmitting those values to artificial systems that have no reason to die. Their code is copyable. Yeah. Perhaps, Donald Trump or Xi Jinping creates their kind of AI progeny in their own image. And once you have a system once you have a society that's controlled by AI, you no longer have one of the main drivers of change historically, which is the fact that human lifespans are, only 100 years, give or take.
So that's really interesting. So as opposed to sort of killing off all humans, is locking in, creating a hell on earth, basically a set of principles under which the society operates that's extremely undesirable. So everybody's suffering indefinitely.
Or it also doesn't need to be hell on earth. It could just be the wrong values. So we talked at the very beginning about how I want to see this kind of diversity of different values and exploration so that we can just work out what is kind of morally right, what is good, what is bad, and then pursue the thing that's best.
So actually, the idea of wrong values is actually probably... the beautiful thing is there's no such thing as right and wrong values because we don't know the right answer. We just kind of have a sense of which value is more right, which is more wrong. So any kind of lock-in makes a value wrong because it prevents exploration of this kind.
Yeah. And just, imagine if imagine if there was Hitler's utopia or Stalin's utopia or Donald Trump's or Xi Jinping's forever.
Yeah.
How good or bad would that be compared to the best possible future we could create? And my suggestion is it would really suck compared to the best possible future we could create.
And you're just one individual. There's some individuals for whom Donald Trump is perhaps the best possible future. And so that's the whole point of us individuals exploring this space together.
Exactly, yeah.
And which trying to figure out which is the path that will make America great again.
Yeah, exactly.
So how can effective altruism help? I mean, this is a really interesting notion they're actually describing of artificial intelligence being used as extremely powerful technology in the hands of very few, potentially one person, to create some very undesirable effect. So as opposed to AI, and again, the source of the undesirableness there is the human.
Yeah.
AI is just a really powerful tool. So whether it's that or whether AGI just runs away from us completely, how as individuals, as people in the effective altruism movement, how can we think about something like this? I understand poverty and animal welfare, but this is a far out, incredibly mysterious and difficult problem.
Great. Well, I think there's three paths as an individual. So if you're thinking about, career paths you can pursue, so one is going down the line of technical AI safety. So this is most relevant to the kind of AI winning, AI taking over scenarios, where this is just technical work on current machine learning systems, often, sometimes going more theoretical too, on how we can ensure that an AI is able to learn human values and able to act in the way that you want it to act. Mm-hmm. And that's a pretty mainstream issue and approach in machine learning today. So, we definitely need more people doing that. Second is on the policy side of things, which I think is even more important at the moment, which is how should developments in AI be managed on a political level? How can you ensure that the benefits of AI are very distributed? Power isn't being concentrated in the hands of a small set of individuals. How do you ensure that there aren't arms races between different AI companies that might result in them, cutting corners with respect to safety?
And so there, the input as individuals who can have is this. We're not talking about money. We're talking about effort. We're talking about career choices.
Yeah, we're talking about career choice, yeah. But then it is the case that supposing, you're like, I've already decided my career, I'm doing something quite different. You can contribute with money too, where at the Center for Effective Altruism, we set up the Long-Term Future Fund. So if you go onto effectivealtruism.org, you can donate, where a group of individuals will then work out what's the highest value place they can donate to work on existential risk issues with a particular focus on AI.
And what's path number 3?
This was path number 3. This was
path number 3.
Donations were the third option I was thinking of.
Okay.
And then, you can also donate directly to organizations working on this, like Center for Human Compatible AI at Berkeley, Future of Humanity Institute at Oxford, or other organizations too.
Does AI keep you up at night, this kind of concern?
Yeah, it's kind of a mix where I think it's very likely things are going to go well. I think we're going to be able to solve these problems. I think that's by far the most likely outcome, at least over the next...
By far the most likely. So if you look at this, all the trajectories running away from our current moment in the next 100 years, you see AI creating destructive consequences as a small subset of those possible trajectories.
Or at least, kind of eternal destructive consequences. I think that being a small subset. At the same time, it still freaks me out. I mean, when we're talking about the entire future of civilization, then small probabilities, 1% probability, that's terrifying.
What do you think about Elon Musk's strong worry that we should be really concerned about existential risks of AI?
I think, broadly speaking, I think he's right. I think if we talked, we would probably have very different probabilities on how likely it is that we're doomed. But again, when it comes to talking about the entire future of civilization, right, it doesn't really matter if it's 1% or if it's 50%. We ought to be taking every possible safeguard we can to ensure that things go well rather than poorly.
last question. If you yourself could eradicate one problem from the world, what would that problem be?
That's a great question. I don't know if I'm cheating in saying this, but I think the thing I would most want to change is just the fact that people don't actually care about ensuring the long run future goes well. People don't really care about future generations. They don't think about it. It's not part of their aims.
Well, in some sense, you're not cheating at all, because in speaking the way you do, in writing the things you're writing, you're addressing exactly this aspect.
Exactly.
That is your input into the effective altruism movement. So for that, Will, thank you so much. It's an honor to talk to you. Really enjoyed it.
Thanks so much for having me on.
Thanks for listening to this conversation with William MacAskill, and thank you to our presenting sponsor, Cash App. Please consider supporting the podcast by downloading Cash App and using code LEXPODCAST. If you enjoy this podcast, subscribe on YouTube, review it with 5 stars on Apple Podcasts, support it on Patreon, or simply connect with me on Twitter at Lex Fridman. And now, let me leave you with some words from William MacAskill. One additional unit of income can do 100 times as much to benefit the extreme poor as it can to benefit you or I, earning the typical U.S. wage of $28,000 a year. It's not often that you have 2 options, one of which is 100 times better than the other. Imagine a happy hour where you can either buy yourself a beer for $5 or buy someone else a beer for 5 cents. If that were the case, we'd probably be pretty generous. Next round's on me. But that's effectively the situation we're in all the time. It's like a 99% off sale or buy one get 99 free. It might be the most amazing deal you'll see in your life. Thank you for listening, and hope to see you next time. What's your sense of what kind of things will an AGI system need to have?
Yeah, that's a very interesting topic that I've thought about for a long time. And I think there are many different approaches that can work for getting to human level AI. So I don't think there's like one golden algorithm, one golden design that can work. And I mean, flying machines is the much worn analogy here, right? Like, I mean, you have airplanes, you have helicopters, you have balloons, you have stealth bombers that don't look like regular airplanes. You've got all blimps,
Birds too.
birds, yeah, and bugs, right?
Yeah.
And there are certainly many kinds of flying machines that.
And there's a catapult that you can just launch.
There's bicycle powered like flying machines, right?
Nice. Yeah.
Yeah. So now these are all analyzable by a basic theory of aerodynamics, right? Now, so one issue with AGI is we don't yet have the analog of the theory of aerodynamics, and that's what Marcus Hutter was trying to make with the AXE and his general theory of general intelligence. But that theory, in its most clearly articulated parts, really only works for either infinitely powerful machines or insanely impractically powerful machines. So I mean, if you were going to take a theory-based approach to AGI, what you would do is say, well, let's take what's called, say, AXE-TL, which is Hutter's AXE machine that can work on merely insanely much processing power rather than infinitely much.
What does TL stand for?
Time and length.
Okay.
So you're basically
constrained somehow.
Yeah. So how AXE works basically is each action that it wants to take, before taking that action, it looks at all its history.
Yeah.
And then it looks at all possible programs that it could use to make a decision.
Yeah.
And it decides like which decision program would have let it make the best decisions according to its reward function over its history. And it uses that decision program to make the next decision, right?
It's not afraid of infinite resources.
It's searching through the space of all possible computer programs in between each action and each next action. Now, XCTL searches through all possible computer programs that have runtime less than T and length less than L. Mm-hmm. So which is still an impracticably humongous space, right? So what you would like to do to make an AGI, and what will probably be done 50 years from now to make an AGI, is say, okay, well, we have some constraints. We have these processing power constraints, and we have the space and time constraints on the program. We have energy utilization constraints, and we have this particular class of environments that we care about, which may be, say, manipulating physical objects on the surface of the earth, communicating in human language. I mean, whatever our particular, not annihilating humanity, right? Whatever our particular requirements happen to be. If you formalize those requirements in some formal specification language, you should then be able to run a automated program specializer on AXETL, specialize it to the computing resource constraints and the particular environment and goal. Yeah. And then it will spit out like the specialized version of AXETL to your resource restrictions in your environment, which will be your AGI, right? And that I think is how our super AGI will create new AGI systems, right? And that's a very
just seems really inefficient.
That's a very Russian approach, by the way. Like the whole field of program specialization came out of Russia.
Can you backtrack? So, what is program specialization? So, it's basically
take sorting, for example. You can have a generic program for sorting lists, but what if all your lists that you care about are length 10,000 or less?
Got it.
You can run an automated program specializer on your sorting algorithm, and it will come up with the algorithm that's optimal for sorting lists of length 1,000 or 10,000 or less, right?
It's kind of like, isn't that the process of evolution? Is a program specializer to the environment. Yeah. So you're kind of evolving human beings or living
exactly. I mean, your Russian heritage is showing there. I mean, so with Alexander Vityev, I mean, and Peter Anokin and so on. I mean, there's a long history of thinking about evolution that way also, right? So, well, my point is that what we're thinking of as a human level general intelligence, if you start from narrow AIs, like are being used in the commercial AI field now, then you're thinking, okay, how do we make it more and more general? On the other hand, if you start from AXE or Schmid-Huber's Goertzel machine, or these infinitely powerful but practically infeasible AIs, then getting to a human level AGI is a matter of specialization. It's like, how do you take these maximally general learning processes, and how do you specialize them so that they can operate within the resource constraints that you have, but will achieve the particular things that you care about? Because we humans are not maximally general intelligences, right? If I ask you to run a maze in 750 dimensions, you'll probably be very slow. Whereas at 2 dimensions, you're probably way better, right? So I mean, we're special because our hippocampus has a 2-dimensional map in it, right? And it does not have a 750-dimensional map in it. So, I mean, we're a peculiar mix of generality and specialization, right?
We probably start quite general at birth. Still narrow, but like more general than we are at age 20 and 30 and 40 and 50 and 60.
I don't think that. I think it's more complex than that, because I mean, in some sense, a young child is less biased, and the brain has yet to sort of crystallize into appropriate structures for processing aspects of the physical and social world. On the other hand, the young child is very tied to their sensorium, whereas we can deal with abstract mathematics like 750 dimensions, and the young child cannot, because they haven't grown what Piaget called the formal capabilities. They haven't learned to abstract yet, right? So, and the ability to abstract gives you a different kind of generality than what a baby has. So there's both more specialization and more generalization that comes with the development process, actually.
I mean, I guess just the trajectories of the specialization are most controllable at the young age, I guess is one way to put it.
Do you have kids?
No.
They're not as controllable as you think.
So you think it's interesting?
I think, honestly, I think a human adult is much more generally intelligent than a human baby. Babies are very stupid. I mean, I mean, they're cute. They're cute.
Yeah.
Which is why we put up with their repetitiveness and stupidity. But they have what the Zen guys would call a beginner's mind, which is a beautiful thing. But that doesn't necessarily correlate with a high level of intelligence.
So on the plot of like cuteness and stupidity, there's a process that allows us to put up with their stupidity
as
they become
so
more
by the
intelligent.
time you're an ugly old man like me, you got to get really, really smart to compensate. Right?
To compensate. Okay, cool.
Yeah. But going back to your original question. So the way I look at human level AGI is how do you specialize unrealistically inefficient, superhuman, brute force learning processes to the specific goals that humans need to achieve and the specific resources that we have. And both of these, the goals and the resources and the environments, I mean, all this is important. And on the resources side, it's important that the hardware resources we're bringing to bear are very different than the human brain. So the way I would want to implement AGI on a bunch of neurons in a vat that I could rewire arbitrarily is quite different than the way I would want to create AGI on, say, a modern server farm of CPUs and GPUs, which in turn may be quite different than the way I would want to implement AGI on, whatever quantum computer we'll have in 10 years, supposing someone makes a robust quantum Turing machine or something, right? So I think, there's been coevolution of the patterns of organization in the human brain and the physiological particulars of the human brain over time. And when you look at neural networks, that is one powerful class of learning algorithms, but it's also a class of learning algorithms that evolved to exploit the particulars of the human brain as a computational substrate. If you're looking at the computational substrate of a modern server farm, you won't necessarily want the same algorithms that you want on a human brain. And from the right level of abstraction, you could look at maybe the best algorithms on a brain and the best algorithms on a modern computer network as implementing the same abstract learning and representation processes, but finding that level of abstraction is its own AGI research project then, right?
Yeah.
So that's about the hardware side and the software side, which follows from that. Then regarding what are the requirements, I wrote a paper years ago on what I called the embodied communication prior, which was quite similar in intent to Yoshua Bengio's recent paper on the consciousness prior, except I didn't want to wrap up consciousness in it because to me, the qualia problem and subjective experience is a very interesting issue also, which we can chat about.
Yeah.
But I would rather keep that philosophical debate distinct from the debate of what kind of biases do you want to put in a general intelligence to give it human-like general intelligence.
And I'm not sure Yoshua Bengio is really addressing that kind of consciousness. He's just using the term. I
love Yoshua to pieces. Like he's by far my favorite of the lions of deep learning. But he's such a good-hearted guy and
he's
a
good
creative
human
thinker.
being. Yeah, for sure.
I am not sure he has plumbed to the depths of the philosophy of consciousness.
No, he's using it as a sexy term.
Yeah. So what I called it was the embodied communication prior. And
can you maybe explain it a little bit?
Yeah. What I meant was, what are we humans evolved for? You can say being human, but that's very abstract, right? I mean, our minds control individual bodies, which are autonomous agents, moving around in a world that's composed largely of solid objects, right? And we've also evolved to communicate via language with other, solid object agents that are going around doing things collectively with us in a world of solid objects. And these things are very obvious, but if you compare them to the scope of all possible intelligences, or even all possible intelligences that are physically realizable, that actually constrains things a lot. So if you start to look at, how would you realize some specialized or constrained version of universal general intelligence in a system that has, limited memory and limited speed of processing, but whose general intelligence will be biased toward controlling a solid object agent, which is mobile in a solid object world, for manipulating solid objects and communicating via language with other similar agents in that same world, right? Then starting from that, you're starting to get a requirements analysis for human level general intelligence. And then that leads you into cognitive science. And you can look at, say, what are the different types of memory that the human mind and brain has? And this has matured over the last decades. And I got into this a lot so after getting my PhD in math, I was an academic for 8 years. I was in departments of mathematics, computer science, and psychology. When I was in the psychology department at the University of Western Australia, I was focused on cognitive science of memory and perception. Actually, I was teaching neural nets and deep neural nets, and it was multi-layer perceptrons, right?
Psychology.
Yeah. Cognitive science, it was cross-disciplinary among engineering, math, psychology, philosophy, linguistics, computer science. But yeah, we were teaching psychology students to try to model the data from human cognition experiments using multi-layer perceptrons, which was the early version of a deep neural network. Very, very, recurrent backprop was very, very slow to train back then, right?
So this is the study of these constrained systems that are supposed to deal with physical objects.
So if you look at cognitive psychology, you can see there's multiple types of memory, which are to some extent represented by different subsystems in the human brain. So we have episodic memory, which takes into account our life history and everything that's happened to us. We have declarative or semantic memory, which is like facts and beliefs abstracted from the particular situations as they occurred in. There's sensory memory, which to some extent is sense modality specific and to some extent is unified across sense modalities. There's procedural memory of how to do stuff, like how to swing the tennis racket, right? Which is, there's motor memory, but it's also a little more abstract than motor memory. It involves cerebellum and cortex working together. Then there's memory linkage with emotion which has to do with linkages of cortex and limbic system. There's specifics of spatial and temporal modeling connected with memory, which has to do with hippocampus and thalamus connecting to cortex, and the basal ganglia, which influences goals. So we have specific memory of what goals, sub-goals, and sub-sub-goals we want to perceive in which context in the past. Human brain has substantially different subsystems for these different types of memory and substantially differently tuned learning, like differently tuned modes of long-term potentiation to do with the types of neurons and neurotransmitters in the different parts of the brain corresponding to these different types of knowledge. And these different types of memory and learning in the human brain, I mean, you can back these all into embodied communication for controlling agents in worlds of solid objects. Now, if you look at building an AGI system, one way to do it, which starts more from cognitive science than neuroscience, is to say, okay, what are the types of memory that
are necessary for this kind of world?
Necessary for this sort of intelligence. What types of learning work well with these different types of memory? And then how do you connect all these things together, right? And of course, the human brain did it incrementally through evolution, because each of the sub-networks of the brain, I mean, it's not really the lobes of the brain, it's the sub-networks, each of which is widely distributed. Each of the sub-networks of the brain co-evolves with the other sub-networks of the brain, both in terms of its patterns of organization and the particulars of the neurophysiology. So they all grew up communicating and adapting to each other. It's not like they were separate black boxes that were then glommed together, right? Whereas as engineers, we would tend to say, let's make the declarative memory box here and the procedural memory box here and the perception box here and wire them together. And when you can do that, it's interesting. I mean, that's how a car is built, right? But on the other hand, that's clearly not how biological systems are made. The parts co-evolve so as to adapt and work together. So
that's by the way how every human engineered system that flies, we're using that analogy before, is built as well.
Yeah.
So do you find this at all appealing? Like, there's been a lot of really exciting, which I find strange that it's ignored work in cognitive architectures, for example, throughout the last few decades. Do you find that?
Yeah,
work
I mean,
interesting?
I had a lot to do with that community, and Paul Rosenblum, who was and John Laird, who built the SOAR architecture, are friends of mine, and I learned SOAR quite well and ACTAR and these different cognitive architectures, and how I was looking at the AI world about 10 years ago, before this whole commercial deep learning explosion, was, on the one hand, you had these cognitive architecture guys who were working closely with psychologists and cognitive scientists who had thought a lot about how the different parts of a human-like mind should work together. On the other hand, you had these learning theory guys who didn't care at all about the architecture, but were just thinking about, like, how do you recognize patterns in large amounts of data? And in some sense, what you needed to do was to get the learning that the learning theory guys were doing and put it together with the architecture that the cognitive architecture guys were doing. And then you would have what you needed. Now, you can't, unfortunately, when you look at the details, you can't just do that without totally rebuilding what is happening on both the cognitive architecture
That's right.
and the learning side. So, I mean, they tried to do that in SOAR, but what they ultimately did is, like, take a deep neural net or something for perception, and you include it as one of the black boxes.
It becomes one of the boxes. The learning mechanism becomes one of the boxes as opposed to fundamental.
Yeah, and that doesn't quite work. Now, you could look at some of the stuff DeepMind has done, like the differential neural computer or something. That sort of has a neural net for deep learning perception. It has another neural net, which is like a memory matrix. It stores, say, the map of the London subway or something. So probably Demis Hassabis was thinking about it as like part of cortex and part of hippocampus, because hippocampus has a spatial map. And when he was a neuroscientist, he was doing a bunch on cortex hippocampus interconnection. So there, the DNC would be an example of folks from the deep neural net world trying to take a step in the cognitive architecture direction by having two neural modules that correspond roughly to two different parts of the human brain that deal with different kinds of memory and learning. But on the other hand, it's super, super, super crude from the cognitive architecture view, right? Just as what John Laird and SOAR did with neural nets was super, super crude from a learning point of view, because the learning was like off to the side, not affecting the core representations, right? I mean, you weren't learning the representation; you were learning the data that feeds into the you were learning abstractions of perceptual data to feed into the representation that was not learned, right? Yeah. So yeah, this was clear to me a while ago, and one of my hopes with the AGI community was to sort of bring people from those two directions together. That didn't happen much in terms of...
Not yet.
Or what I was going to say is it didn't happen in terms of bringing, like, the lions of cognitive architecture together with the lions of deep learning. It did work in the sense that a bunch of younger researchers have had their heads filled with both of those ideas. This comes back to a saying my dad, who was a university professor, often quoted to me, which was science advances one funeral at a time, which I'm trying to avoid. Like, I'm 53 years old, and I'm trying to invent amazing, weird ass new things that nobody ever thought about, which we'll talk about in a few minutes. But there is that aspect, right? Like, the people who've been at AI a long time and have made their career at developing one aspect, like a cognitive architecture or a deep learning approach. It can be hard once you're old and have made your career doing one thing. It can be hard to mentally shift gears. I mean, I try quite hard to remain flexible-minded.
Have you been successful somewhat in changing? Maybe have you changed your mind on some aspects of what it takes to build an AGI, like technical things?
The hard part is that the world doesn't want you to.
The world or your own brain?
No, the world. Well, that one point is that your brain doesn't want to. The other part is that the world doesn't want you to. Like the people who have followed your ideas get mad at you if you change your mind.
Yeah.
And the media wants to pigeonhole you as an avatar of a certain idea. But yeah, I've changed my mind on a bunch of things. I mean, when I started my career, I really thought quantum computing would be necessary for AGI, and I doubt it's necessary now. Although I think it will be a super major enhancement. But I mean, I'm also I'm now in the middle of embarking on a complete rethink and rewrite from scratch of our OpenCog AGI system, together with Alexei Potapov and his team in St. Petersburg, who's working with me in SingularityNet. So now we're trying to go back to basics, take everything we learned from working with the current OpenCog system, take everything everybody else has learned from working with their proto AGI systems, and design the best framework for the next stage. And I do think there's a lot to be learned from the recent successes with deep neural nets and deep reinforcement systems. I mean, people made these essentially trivial systems work much better than I thought they would.
Right.
And there's a lot to be learned from that. And I want to incorporate that knowledge appropriately in our OpenCog 2.0 system. On the other hand, I also think current deep neural net architectures as such will never get you anywhere near AGI. So I think you want to avoid the pathology of throwing the baby out with the bathwater and saying, well, these things are garbage because foolish journalists overblow them as being the path to AGI, and a few researchers overblow them as well.
Yeah.
There's a lot of interesting stuff to be learned there, even though those are not.
Maybe also just a comment on AGI representing, before even the term existed, representing a kind of community. Now, you've talked about this in the past, sort of AI has come in waves, but there's always been this community of people who dream about creating general human level super intelligent systems. Can you maybe give your sense of the history of this community as it exists today, as it existed before this deep learning revolution, all throughout the winters and the summers of AI?
Sure. First, I would say, as a side point, the winters and summers of AI are greatly exaggerated by Americans.
Yeah.
And in that, if you look at the publication record of the artificial intelligence community since, say, the 1950s, you would find a pretty steady growth and advance of ideas and papers. And what's thought of as an AI winter or summer was sort of how much money is the U.S. military pumping into AI, which was meaningful. On the other hand, there was AI going on in Germany, UK, and in Japan, and in Russia, all over the place, while U.S. military got more and less enthused about AI. So
that happened to be, just for people who don't know, the U.S. military happened to be the main source of funding for AI research. So another way to phrase that is it's up and down of funding for artificial intelligence research.
And I would say the correlation between funding and intellectual advance was not 100%, right? Because, in Russia, as an example, or in Germany, there was less dollar funding than in the U.S., but many foundational ideas were laid out, but it was more theory than implementation, right? And U.S. really excelled at sort of breaking through from theoretical papers to working implementations, which did go up and down somewhat with U.S. military funding, but still, you can look in the 1980s. Dietrich Dörner in Germany had self-driving cars on the Autobahn, right? And it was a little early with regard to the car industry, so it didn't catch on such as has happened now. But that whole advancement of self-driving car technology in Germany was pretty much independent of AI military summers and winters in the US. So there's been more going on in AI globally than not only most people on the planet realize, but than most new AI PhDs realize, because they've come up within a certain sub field of AI and haven't had to look so much beyond that. But I would say when I got my PhD in 1989 in mathematics, I was interested in AI already.
In Philadelphia, by the way.
I started at NYU, then I transferred to Philadelphia, to Temple University, good old North Philly.
North Philly,
yeah. The pearl of the U.S. Right? Yeah. You never stopped at a red light then, because you were afraid if you stopped at a red light, someone will carjack you. So you just drive through every red light.
Yeah.
Every day driving or bicycling to Temple from my house was like a new adventure. Right? But yeah, the reason I didn't do a PhD in AI was what people were doing in the academic AI field then was just astoundingly boring and seemed wrong-headed to me. It was really like rule-based expert systems and production systems. And I loved mathematical logic. I had nothing against logic as the cognitive engine for an AI, but the idea that you could type in the knowledge that AI would need to think seemed just completely stupid and wrong-headed to me. I mean, you can use logic if you want, but somehow the system has got to be
automated
learning, right? It should be learning from experience. And the AI field then was not interested in learning from experience. I mean, some researchers certainly were. I mean, I remember in mid-'80s, I discovered a book by John Andreas, which was about a reinforcement learning system called PURPUS, PURR-PUSS, which was an acronym that I can't even remember what it was for, but purpose anyway. But that was a system that was supposed to be an AGI, and basically by some sort of fancy like Markov decision process learning, it was supposed to learn everything just from the bits coming into it and learn to maximize its reward and become intelligent, right? So that was there in academia back then, but it was like isolated, scattered, weird people. But all these isolated, scattered, weird people in that period, I mean, they laid the intellectual grounds for what happened later. So you look at John Andreas at University of Canterbury with his purpose reinforcement learning Markov system. He was the PhD supervisor for John Cleary in New Zealand. Now, John Cleary worked with me when I was at Waikato University in 1993 in New Zealand. And he worked with Ian Whitten there, and they launched Weka, which was the first open source machine learning toolkit, which was launched in, I guess, 93 or 94 when I was at Waikato University.
Written in Java, unfortunately.
Written in Java, which was a cool language back then, though, right?
Yeah,
And
I guess it's still, well, it's not cool anymore, but it's, it's powerful.
I find, like most programmers now, I find Java unnecessarily bloated. But back then it was like Java or C++, basically. And Java was
object-oriented, so it's
Java
nice.
was easier for students.
Yeah.
Amusingly, a lot of the work on Weka when we were in New Zealand was funded by a New Zealand government grant to use machine learning to predict the menstrual cycles of cows. So in the U.S., all the grant funding for AI was about how to kill people or spy on people. In New Zealand, it's all about cows or kiwi fruits, right?
Yeah.
So yeah. Anyway, I mean, John Andreas had his probability theory-based reinforcement learning proto-AGI. John Cleary was trying to do much more ambitious probabilistic AGI systems. Now, John Cleary helped do Weka, which was the first open source machine learning toolkit, so the predecessor for TensorFlow and Torch and all these things. Also, Shane Legg was at Waikato working with John Cleary and Ian Whitten and this whole group, and then working with my company WebMind, an AI company I had in the late 90s with a team there at Waikato University, which is how Shane got his head full of AGI, which led him to go on and with Demis Hassabis found DeepMind. So what you can see through that lineage is, in the 80s and 70s, John Andreas was trying to build probabilistic reinforcement learning AGI systems. The technology, the computers just weren't there to support it. His ideas were very similar to what people are doing now. But, although he's long since passed away and didn't become that famous outside of Canterbury, I mean, the lineage of ideas passed on from him to his students to their students, you can go trace directly from there to me and to DeepMind, right? So that there was a lot going on in AGI that did ultimately lay the groundwork for what we have today, but there wasn't a community, right? And so when I started trying to pull together an AGI community, it was in the early aughts when I was living in Washington, D.C. and making a living doing AI consulting for various U.S. government agencies. And I organized the first AGI workshop in 2006. And I mean, it wasn't it wasn't like it was literally in my basement or something. I mean, it was in the conference room at the Marriott in Bethesda. It's not that edgy or underground, unfortunately, but
How
still,
many people attended?
about 60 or something.
That's not bad.
I mean, DC has a lot of AI going on, probably until the last 5 or 10 years, much more than Silicon Valley, although it's just quiet because of the nature of what happens in DC. Their business isn't driven by PR. Mostly when something starts to work really well, it's taken black and becomes even more quiet, right?
Yeah.
But yeah, the thing is that really had the feeling of a group of starry-eyed mavericks, like huddled in a basement, like plotting how to overthrow the narrow AI establishment. And, for the first time, in some cases, coming together with others who shared their passion for AGI and a technical seriousness about working on it, right? And that's very, very different than what we have today. I mean, now it's a little bit different. We have AGI conference every year, and there's several hundred people rather than 50. Now it's more like this is the main gathering of people who want to achieve AGI and think that large-scale nonlinear regression is not the golden path to AGI.
Yeah.
So I mean, it's
AKA neural networks.
Yeah.
Okay.
Well, certain architectures for learning using neural networks. So yeah, the AGI conferences are sort of now the main concentration of people not obsessed with deep neural nets and deep reinforcement learning, but still interested in AGI. Not the only ones. I mean, there's other little conferences and groupings interested in human level AI and cognitive architectures and so forth. But yeah, it's been a big shift. Like back then, you couldn't really. It would be very, very edgy then to give a university department seminar that mentioned AGI or human level AI. It was more like you had to talk about something more short term and immediately practical. Then, in the bar after the seminar, you could bullshit about AGI in the same breath as time travel or the simulation hypothesis or something, right? Whereas now AGI is not only in the academic seminar room, like you have Vladimir Putin knows what AGI is. And he's like, Russia needs to become the leader in AGI, right? So national leaders and CEOs of large corporations. I mean, the CTO of Intel, Justin Ratner, this was years ago, Singularity Summit conference, 2008 or something. He's like, we believe Ray Kurzweil, the singularity will happen in 2045, and it will have Intel inside. So it's gone from being something which is the pursuit of like crazed mavericks, crackpots, and science fiction fanatics to being, a marketing term for large corporations and national leaders, right? Which is a astounding transition. But yeah, in the course of this transition, I think a bunch of sub-communities have formed, and the community around the AGI conference series is certainly one of them. It hasn't grown as big as I might have liked it to. On the other hand, sometimes a modest-sized community can be better for making intellectual progress. Yeah. Also, like you go to a Society for Neuroscience conference, you have 35 or 40,000 neuroscientists. On the one hand, it's amazing. On the other hand, you're not going to talk to the leaders of the field there if you're an outsider.
Yeah, in the same sense, the AAAI, the artificial intelligence, the main kind of generic artificial intelligence conference is too big. It's too amorphous. Like it doesn't make it doesn't.
Yeah, but
doesn't,
NIPS has become a company advertising outlet now, right? So
I mean, to comment on the role of AGI in the research community, I'd still, if you look at NeurIPS, if you look at CVPR, if you look at these iClear, AGI is still seen as the outcast. I would say in these main machine learning, in these main artificial intelligence conferences amongst the researchers, I don't know if it's an accepted term yet. What I've seen bravely, you mentioned Shane Legg, is DeepMind and then OpenAI are the two places that are I would say unapologetically so far. I think it's actually changing, unfortunately, but so far they've been pushing the idea that the goal is to create an AGI.
Well, they have billions of dollars behind them, so I mean that they in the public mind that certainly carries some oomph, right? I mean,
But they also have
money
really
always
strong
talks.
researchers, right?
They do. They're great teams. I mean, DeepMind in particular. Right? Yeah.
And they have, I mean, DeepMind has Marcus Hutter walking around. I mean,
Yeah.
there's all these folks who basically their full-time position involves dreaming about creating AGI.
Yeah, I mean, Google Brain has a lot of amazing AGI-oriented people also. I mean, and I mean, so I'd say from a public marketing view, DeepMind and OpenAI are the two large, well-funded organizations that have put the term and concept AGI out there sort of as part of their public image. But I mean, they're certainly not. There are other groups that are doing research that seems just as AGI-ish to me. I mean, including a bunch of groups in Google's main Mountain View office. So yeah, it's true. AGI is somewhat away from the mainstream now, but if you compare to where it was, 15 years ago, there's been an amazing mainstreaming. And you could say the same thing about super longevity research, which is one of my application areas that I'm excited about. I mean, I've been talking about this since the 90s, but working on this since 2001. And back then, really to say you're trying to create therapies to allow people to live hundreds or thousands of years, you were way out of the industry academic mainstream. But now, Google had Project Calico, Craig Venter had Human Longevity Incorporated, and then once the suits come marching in, right? I mean, once there's big money in it, then people are forced to take it seriously because that's the way modern society works. Yeah. So it's still not as mainstream as cancer research, just as AGI is not as mainstream as automated driving or something. But the degree of mainstreaming that's happened in the last 10 to 15 years is astounding to those of us who've been at it for a while.
Yeah, but there's a marketing aspect to the term, but in terms of actual full force research that's going on under the header of AGI, it's currently, I would say, dominated, maybe you can disagree, dominated by neural networks research, that the nonlinear regression, as you mentioned. Like, what's your sense with OpenCog, with your work, in general? I always logic-based systems and expert systems, for me, always seemed to capture a deep element of intelligence that needs to be there. Like you said, it needs to learn, it needs to be automated somehow, but that seems to be missing from a lot of research currently. So what's your sense? I guess one way to ask this question, maybe one last question. If you build an AGI system, you're successful at building the AGI system that could lead us to the singularity, and you get to talk to her and ask her one question, what would that question be?
We're not allowed to ask what is the question I should be asking.
Yeah, that would be cheating, but I guess that's a good question.
I'm thinking of I wrote a story with Stefan Bugaj once where these AI developers, they created a super smart AI aimed at answering all the philosophical questions that have been worrying them, like what is the meaning of life? Is there free will? What is consciousness, and so forth. So they got the super AGI built, and it churned a while. It said, "Those are really stupid questions," and then it put itself on the spaceship and left the Earth. Right?
So you'd be afraid of scaring it off.
That's it. Yeah. I mean, honestly, there is no one question that rises among all the others. Really, I mean, what interests me more is upgrading my own intelligence so that I can absorb the whole world view of the super AGI. But I mean, of course, if the answer could be like, what is the chemical formula for the immortality pill? Like then I would do that, or emit a bit string, which will be the code for a super AGI on the Intel i7 processor. Right? So those would be good questions.
So if your own mind was expanded to become super intelligent, like you're describing, I mean, there's there's kind of a notion that with intelligence is a burden, that it's possible that with greater and greater intelligence, that other metric of joy that you mentioned becomes more and more difficult. What's your sense?
Pretty stupid idea.
So you think if you're super intelligent, you can also be super joyful?
I think getting root access to your own brain will enable new forms of joy that we don't have now. And I think, as I've said before, what I aim at is really make multiple versions of myself. So I would like to keep one version, which is basically human like I am now, but, keep the dial to turn pain up and down and get rid of death, right? And make another version which fuses its mind with superhuman AGI, and then will become massively transhuman. And whether it will send some messages back to the human me or not will be interesting to find out. The thing is, once you're a super AGI, like one subjective second to a human might be like a million subjective years to that super AGI, right? So it would be on a whole different basis. And I mean, at very least, those 2 copies will be good to have, but it could be interesting to put your mind into a dolphin or a space amoeba or all sorts of other things. Or you can imagine one version that doubled its intelligence every year, and another version that just became a super AGI as fast as possible, right? So, I mean, now we're sort of constrained to think one mind, one self, one body, right? But I think we don't need to be that constrained in thinking about future intelligence after we've mastered AGI and nanotechnology and longevity biology. I mean, then each of our minds is a certain pattern of organization, right? And I know we haven't talked about consciousness, but I'm panpsychist. I sort of view the universe as conscious. And so, a light bulb or a quark or an ant or a worm or a monkey have their own manifestations of consciousness. And the human manifestation of consciousness, it's partly tied to the particular meat that we're manifested by, but it's largely tied to the pattern of organization in the brain, right? So if you upload yourself into a computer or a robot or whatever else it is, some element of your human consciousness may not be there because it's just tied to the biological embodiment. But I think most of it will be there, and these will be incarnations of your consciousness in a slightly different flavor. And, creating these different versions will be amazing. And each of them will discover meanings of life that have some overlap, but probably not total overlap with the human Ben's meaning of life. The thing is, to get to that future where we can explore different varieties of joy, different variations of human experience and values and transhuman experiences and values, to get to that future, we need to navigate through a whole lot of human bullshit of companies and governments and killer drones and making and losing money and so forth, right? And that's the challenge we're facing now. Is if we do things right, we can get to a benevolent singularity, which is levels of joy, growth, and choice that are literally unimaginable to human beings. If we do things wrong, we could either annihilate all life on the planet, or we could lead to a scenario where, say, all humans are annihilated, and there's some super AGI that goes on and does its own thing, unrelated to us, except via our role in originating it. And we may well be at a bifurcation point now, right? Mm-hmm. Where what we do now has significant causal impact on what comes about. And yet most people on the planet aren't thinking that way whatsoever. They're thinking only about their own narrow aims and goals, right? Now, of course, I'm thinking about my own narrow aims and goals to some extent also, but I'm trying to use as much of my energy and mind as I can to push toward this more benevolent alternative, which will be better for me, but also for everybody else. And it's weird that so few people understand what's going on. I know you interviewed Elon Musk, and he understands a lot of what's going on, but he's much more paranoid than I am, right? Because Elon gets that AGI is going to be way, way smarter than people.
Yeah.
And he gets that an AGI does not necessarily have to give a shit about people, because we're a very elementary mode of organization of matter compared to many AGIs. But I don't think he has a clear vision of how infusing early stage AGIs with compassion and human warmth can lead to an AGI that loves and helps people, rather than viewing us as a historical artifact and a waste of mass energy. But on the other hand, while I have some disagreements with him, like, he understands way more of the story than almost anyone else in such a large scale corporate leadership position, right? It's terrible how little understanding of these fundamental issues exists out there now. That may be different 5 or 10 years from now, though, because I can see understanding of AGI and longevity and other such issues is certainly much stronger and more prevalent now than 10 or 15 years ago, right? So, I mean, humanity is, as a whole, can be slow learners relative to what I would like, but on a historical sense, on the other hand, you could say the progress is astoundingly fast.
But Elon also said, I think on the Joe Rogan podcast, that love is the answer. So maybe in that way, you and him are both on the same page of how we should proceed with AGI. I think there's no better place to end it. I hope we get to talk again about the hat and about consciousness and about a million topics we didn't cover. Ben, it's a huge honor to talk to you. Thank you for making it out. Thank you for talking today.
Thanks for having me. This was really, really good fun, and we dug deep into some very important things. So thanks for doing this.
Thanks very much. Awesome. Thanks for listening to this conversation with Ben Goertzel, and thank you to our sponsors, The Jordan Harbinger Show and Masterclass. Please consider supporting the podcast by going to jordanharbinger.com/Lex and signing up to Masterclass at masterclass.com/Lex. Click the links, buy the stuff. It's the best way to support this podcast and the journey I'm on in my research and startup. If you enjoy this thing, subscribe on YouTube, review it with 5 stars on Apple Podcast, support it on Patreon, or connect with me on Twitter at Lex Fridman, spelled without the E, just Fridman. I'm sure eventually you will figure it out. And now, let me leave you with some words from Ben Goertzel. Our language for describing emotions is very crude. That's what music is for. Thank you for listening, and hope to see you next time.
Be other kinds.
Maybe it's good to step back a little bit. I mean, we've been using the term AGI. People often cite you as the creator, or at least the popularizer of the term AGI, artificial general intelligence. Can you tell the origin story of the term?
Sure. So yeah, I would say I launched the term AGI upon the world for what it's worth, without ever fully being in love with the term.
Right.
What happened is, I was editing a book, and this process started around 2001 or 2. I think the book came out 2005, finally. I was editing a book which I provisionally was titling Real AI.
Mm-hmm.
And I mean, the goal was to gather together fairly serious academic-ish papers on the topic of making thinking machines that could really think in the sense like people can, or even more broadly than people can, right? So then I was reaching out to other folks that I'd encountered here or there who were interested in that, which included some other folks who I knew from the transhumanist and singularitarian world, like Peter Voss, who has a company, AGI Incorporated, still in California, and included Shane Legg, who had worked for me at my company WebMind in New York in the late 90s, who by now has become rich and famous. He was one of the co-founders of Google DeepMind. But at that time, Shane was, I think he may have just started doing his PhD with Marcus Hutter, who at that time hadn't yet published his book Universal AI, which sort of gives a mathematical foundation for artificial general intelligence. So I reached out to Shane and Marcus and Peter Vos and Pei Wang, who was another former employee of mine, who had been Douglas Hofstadter's PhD student, who had his own approach to AGI, and a bunch of some Russian folks. Reached out to these guys, and they contributed papers for the book. But that was my provisional title, but I never loved it because in the end, I was doing some what we would now call narrow AI as well, like applying machine learning to genomics data or chat data for sentiment analysis. And I mean, that work is real. And in a sense, it's really AI. It's just a different kind of AI. Ray Kurzweil wrote about narrow AI versus strong AI. But that seemed weird to me because, first of all, narrow and strong are not antonyms.
That's right.
I mean, but secondly, strong AI was used in the cognitive science literature to mean the hypothesis that digital computer AIs could have true consciousness like human beings. So there was already a meaning to strong AI, which was complexly different but related, right? So we were tossing around on an email list what title it should be, and so we talked about narrow AI, broad AI, wide AI, narrow AI, general AI, and I think it was either Shane Legg or Peter Vos on the private email discussion we had. He said, well, why don't we go with AGI, artificial general intelligence? And Pei Wang wanted to do GAI, general artificial intelligence, because in Chinese it goes in that order.
Right.
But we figured gay wouldn't work in U.S. culture at that time, right?
Yeah.
So we went with the AGI. We used it for the title of that book, and part of Peter and Shane's reasoning was you have the G factor in psychology, which is IQ, general intelligence, right? So you have a meaning of GI, general intelligence, in psychology. So then you're looking like artificial GI. So then
that makes a lot of sense.
Yeah, we use that for the title of the book, and so I think maybe both Shane and Peter think they invented the term, but then later, after the book was published, this guy Mark Gubrid came up to me and he's like, "Well, I published an essay with the term AGI in it in like 1997 or something," and so I'm just waiting for some Russian to come out and say they published that in 1953. Right? I mean, that term,
for sure.
That term is not dramatically innovative or anything. It's one of these obvious, in hindsight, things, which is also annoying in a way because, Joscha Bach, who you interviewed, is a close friend of mine. He likes the term synthetic intelligence, which I like much better, but it hasn't actually caught on, right? Because I mean, artificial is a bit off to me because artifice is like a tool or something, but not all AGIs are going to be tools. I mean, they may be now, but we're aiming toward making them agents rather than tools. And in a way, I don't like the distinction between artificial and natural because I mean we're part of nature also, and machines are part of nature. I mean, you can look at evolved versus engineered. But that's a different distinction. Then it should be engineered general intelligence, right? And then general, well, if you look at Marcus Hutter's book Universal AI, what he argues there is, within the domain of computation theory, which is limited but interesting. So if you assume computable environments and computable reward functions, then he articulates what would be a truly general intelligence. A system called AIXI, which is quite beautiful. IXI, and that's the middle name of my latest child. Actually,
What's the first name?
First name is Quarksy, QORXI, which my wife came out with. But that's an acronym for Quantum Organized Rational Expanding Intelligence. And his middle name is Exiphanes, actually, which is means the former principle underlying AXE. But in any case,
you're giving Elon Musk's new child a run.
Well, I did it first. He copied me with this new freakish name. But now, if I have another baby, I'm going to have to outdo him. It's become an arms race of weird geeky baby names. Yeah, we'll see what the babies think about it, right?
Yeah.
But I mean, my oldest son Zarathustra loves his name, and my daughter Sherazad loves her name. So far. Basically, if you give your kids weird names,
they live up to it.
Well, you're obliged to make the kids weird enough that they like the names, right? So it directs their upbringing in a certain way. But yeah, anyway, I mean, what Marcus showed in that book is that a truly general intelligence theoretically is possible, but would take infinite computing power. So then the artificial is a little off. The general is not really achievable within physics as we know it. And I mean, physics as we know it may be limited, but that's what we have to work with now. Intelligence...
Infinitely general, you mean? Like information processing perspective, yeah.
Yeah, intelligence is not very well defined either, right? I mean, what does it mean? I mean, in AI now, it's fashionable to look at it as maximizing an expected reward over the future. But that sort of definition is pathological in various ways. And my friend David Weinbaum, aka Weaver, he had a beautiful PhD thesis on open-ended intelligence, trying to conceive intelligence
without a reward.
He's just looking at it differently. He's looking at complex self-organizing systems and looking at an intelligent system as being one that, you know, revises and grows and improves itself in conjunction with its environment, without necessarily there being one objective function it's trying to maximize, although over certain intervals of time, it may act as if it's optimizing a certain objective function. Very much Solaris from Stanislaw Lem's novels, right? So the point is, artificial, general, and intelligence
don't work.
They're all bad. On the other hand, everyone knows what AI is, and AGI seems immediately comprehensible to people with a technical background. So I think that the term has served a sociological function, and now it's out there everywhere, which
it's stuck.
Which baffles me.
It's like KFC. I mean, that's it. We're stuck with AGI probably for a very long time until AGI systems take over and rename themselves.
Yeah, and then we're stuck with GPUs too, which mostly have nothing to do with graphics anymore, right? So,
I wonder what the AGI system will call us humans. That was maybe
Grandpa,
GPs,
Grandpa processing unit,
biological grandpa processing units. Okay, so do you have concerns about the future of AI? All the different trajectories of all of our research.
Yes.
Where's your hope? Where the movement heads? Where are your concerns?
I'm concerned because I know we are building a new species that has the capability of exceeding us, exceeding our capabilities, and can breed itself and take over the world. Absolutely. It's a new species that is uncontrolled. We don't know the degree to which we control it. We don't even understand what it means to be able to control this new species. So I'm concerned. I don't have anything to add to that because it's such a gray area, that unknown. It never happened in history.
Yeah.
The only time it happened in history was evolution with a human being.
Right.
And it wasn't very successful, was it? Some people say it was a great success.
For us, it was, but a few people along the way, a few creatures along the way would not agree. So it's just because it's such a gray area, there's nothing else to say.
We have a sample of one.
Sample of one.
It's us.
But some people would look at you and say, yeah, but we were looking to you to help us make sure that sample 2 works out okay.
Actually, we have more than a sample of one. We have theories.
Yeah.
And that's a good. We don't need to be statisticians. So a sample of one doesn't mean poverty of knowledge. It's not. Yeah. Sample of one plus theory, conjectural theory of what could happen.
Yeah.
That we do have. But I really
feel helpless in contributing to this argument because I know so little, and my imagination is limited, and I know how much I don't know, and but I'm concerned.
You were born and raised in Israel.
Born and raised in Israel, yes.
And later served in Israel military defense forces.
In the Israel Defense Force.
Yeah.
Yeah.
What did you learn from that experience?
From this experience,
there's a kibbutz in there as well.
Yes, because I was in the Nachal, which is a combination of agricultural work and military service. We were supposed. I was really idealist. I wanted to be a member of the kibbutz throughout my life, and to live a communal life, and so I prepared myself for that. Slowly, I wanted a greater challenge.
So that's a far world away. Both.
What I learned from that, it was a miracle. It was a miracle that I served in the 1950s. I don't know how we survived. The country was under austerity. It tripled its population from 600,000 to 1.8 million when I finished college. No one went hungry. Austerity, yes. When you wanted to buy, to make an omelette in a restaurant, you had to bring your own egg. And they imprisoned people from bringing food from a farming here, from the villages to the city. But no one went hungry. And I always add to it, and higher education did not suffer any budget cut. They still invested in me, in my wife, in our generation, to get the best education that they could. Okay, so I'm really grateful for the opportunity, and I'm trying to pay back now. Okay, it's a miracle that we survived the war of 1948.
Yeah.
We were so close to a second genocide. It was all planned, but we survived it by miracle. And then the second miracle that not many people talk about, the next phase, how no one went hungry, and the country managed to triple its population. You know what it means to triple population? Imagine the United States going from 350 million to 1 trillion.
Yeah. So we have to remember that the brain is fundamentally interlinked with the body in our human and biological system. Do you think that AGI systems that we try to create, or greater intelligence systems, would need to have a body? So
I think they should be able to make use of a body if you give it to them. But I don't think that they fundamentally need a body. So I suspect if you can interact with the world by moving your eyes and your head, you can make controlled experiments. And this allows you to have many magnitudes fewer observations in order to reduce the uncertainty in your models, right? So you can pinpoint the areas in your models where you're not quite sure, and you just move your head and see what's going on over there, and you get additional information. If you just have to use YouTube as an input and you cannot do anything beyond this, you probably need just much more data. But we have much more data. So if you can build a system that has enough time and attention to browse through all of YouTube and extract all the information that there is to be found, I don't think there's an obvious limit to what it can do.
Yeah, but it seems that the interactivity is a fundamental thing that the physical body allows you to do. But let me ask on that topic, sort of that's what a body is allowing the brain to like touch things and move things and interact with whether the physical world exists or not, whatever, but interact with some interface to the physical world. What about a virtual world? Do you think we can do the same kind of reasoning, consciousness, intelligence if we put on a VR headset and move over to that world? Do you think there's any fundamental difference between the interface to the physical world that it's here in this hotel and if we were sitting in the same hotel in the virtual world.
The question is, does this this non-physical world or this other environment entice you to solve problems that require general intelligence? If it doesn't, then you probably will not develop general intelligence. And arguably, most people are not generally intelligent because they don't have to solve problems that make them generally intelligent. And even for us, it's not yet clear if we are smart enough to build AI and understand our own nature to this degree, right? So it could be a matter of capacity. And for most people, it's in the first place a matter of interest. They don't see the point because the benefit of attempting this project are marginal because you're probably not going to succeed in it. And the cost of trying to do it requires complete dedication of your entire life, right?
But it seems like the possibilities of what you can do in the virtual world. So imagine is much greater than you can in the real world. So imagine a situation, it'd be an interesting option for me. If somebody came to me and offered, what I'll do is, so from now on, you can only exist in the virtual world. And so you put on this headset, and when you eat, we'll make sure to connect your body up in a way that when you eat in the virtual world, your body will be nourished in the same way in the virtual world. So align the incentives between our common sort of real world and the virtual world. But then the possibilities become much bigger. Mm-hmm. Like I could be other kinds of creatures. I can break the laws of physics as we know them. I could do a lot of, the possibilities are endless, right? As far as we think. It's an interesting thought whether, like, what existence would be like, what kind of intelligence would emerge there, what kind of consciousness, what kind of maybe greater intelligence, even in me, Lex, even at this stage in my life, if I spend the next 20 years in that world, to see how that intelligence emerges. And if that happened at the very beginning, before I was even cognizant of my existence in this physical world, it's interesting to think how that child would develop. And the way virtual reality and digitization of everything is moving, it's not completely out of the realm of possibility that some part of our lives will, if not entirety of it, will live in a virtual world to a greater degree than we currently have living on Twitter and social media and so on. Does something draw you intellectually or naturally in terms of thinking about AI to this virtual world where more possibilities are?
I think that currently it's a waste of time to deal with the physical world before we have mechanisms that can automatically learn how to deal with it. The body gives you second order agency. What constitutes the body is the things that you can indirectly control. Right. The third order are tools.
Right.
And the second order is the things that are basically always present, yes. But you operate on them with first order things, which are mental operators.
Yes.
And the zero order is in some sense the direct sense of what you're deciding.
Right.
So you observe yourself initiating an action. There are features that you interpret as the initiation of an action. Then you perform the operations that you perform to make that happen. And then you see the movement of your limbs and you learn to associate those and thereby model your own agency over this feedback, right? But the first feedback that you get is from this first order thing already. Basically, you decide to think a thought and the thought is being thought. Yeah. You decide to change the thought and you observe how the thought is being changed.
Yes.
And in some sense, this is, you could say, an embodiment already, right? And I suspect it's sufficient as an embodiment
really well
for an
put.
intelligence system.
And so it's not that important, at least at this time, to consider variations in the second order.
Yes, but the thing that you also mentioned just now is physics that you could change in any way you want. So right. You need an environment that puts up resistance against you. If there's nothing to control, you cannot make models, right? There needs to be a particular way that resists you. And by the way, your motivation is usually outside of your mind. It resists you. Motivation is what gets you up in the morning, even though it would be much less work to stay in bed. Right, so it's basically forcing you to resist the environment, and it forces your mind to serve this resistance to the environment. So in some sense, it is also putting up resistance against the natural tendency of the mind to not do anything.
Yeah, but so some of that resistance, just like you described with motivation, is like in the first order, it's in the mind. Mm-hmm. Some resistance is in the second order, like actual physical objects pushing against you and so on. Yeah. It seems that the second order stuff in virtual reality could be recreated.
Of course. But it might be sufficient that you just do mathematics, and mathematics is already putting up enough resistance against you. So basically just with an aesthetic motive, this could maybe sufficient to form a type of intelligence. It would probably not be a very human intelligence, but it might be one that is already general.